السلام عليكم ورحمة الله وبركاته. أستاذ جمال، أكد لي الصوت واضح.
اي نعم، واضح. الله يعطيك العافية.
أهلا وسهلا بالجميع. نرحب فيكم جميعا في جمعية إدارة المرافق والسلامة بالمنشآت الصحية في المملكة العربية السعودية، جمعية فمسا. معكم محدثكم المهندس مشعل العامري، مؤسس جمعية فمسا ورئيس مجلس الإدارة. ومحاضرتنا هذا اليوم بإذن الله راح نتكلم عن الهازمات أو الهازاردوس ماتيريالز، المواد الخطرة في المنشآت الصحية، وهي عنصر أساسي من ضمن عناصر إدارة المرافق والسلامة. محاضرة قيمة جدا وراح تكون مدتها ساعتين بإذن الله. يحضرنا إن شاء الله في هذه المحاضرة عدد كبير من المنشآت الصحية ومسؤولين السلامة والهازاردوس أو الهازمات ماتيريالز بالمنشآت الصحية. راح تكون إن شاء الله هذه المحاضرة مسجلة للاستفادة منها لاحقا. يوجد شهادات حضور ولكن بشروط محددة. لابد من حضور أقل شيء ساعة ونصف من أصل ساعتين، وهي مدة المحاضرة. وأيضا نرجو التأكد من جميع الأسماء، أن تكون الاسم الصحيح للشخص، لأنه المحاضرة راح تكون مسجلة أوتوماتيك. فبالتالي إذا كان الاسم خطأ راح ما تصدر شهادة حضور. نستضيف في هذا اللقاء الرائع الأستاذ المتميز، الأستاذ جمال الشعار، حاصل على ماجستير في إدارة المخاطر والأزمات والكوارث، ويعمل مستشار في مجال الصحة والسلامة المهنية، بخبرة تزيد عن 20 عاما في قيادة برامج السلامة عبر القطاعات الصحية والصناعية وقطاع الإنشاءات. الأستاذ جمال يعد خبيرا في الالتزام بالمعايير والأنظمة الدولية مثل ال NFPA والأوشا، إضافة إلى الاعتمادات العالمية مثل الآيزو، سباهي، GCI، وله دور بارز في تطبيق أنظمة السلامة المتكاملة. أستاذ جمال يحمل العديد من الشهادات المهنية، من ضمنها ال ESP والنيبوش والآيزو 45، ومدرب معتمد لدورات السلامة مثل الأوشا والهازوبر اللي هي هازاردوس ويست اوبريشنز اند emergency ريسبونس. إضافة إلى أنه مدرب معتمد في هذا المجال، وهو أيضا معتمد كمؤلف ومدرب لعدد من البرامج التدريبية المتخصصة في السلامة بالرعاية الصحية وإدارة المواد الخطرة. له مساهمات كبيرة حقيقة في تطوير البرامج التدريبية والتأهيلية في مجال السلامة. ضيف ثقيل ومميز، راح يقدم لنا محاضرة مختصرة جدا في مجال الهازمات. الهازمات قد يكون يعني قليل نجد فيه مواد تعليمية أو تدريبية، خاصة في الهيلث كير أو في المنشآت الصحية. بالتالي حرصنا أن يكون عنوان محاضرتنا لهذا اليوم في هذا المجال. راح نتكلم عن أساسياته، وأيضا عن التعامل والتخزين وكيفية إدارة هذه أو هذا الجانب في وهو العنصر المهم أيضا في إدارة السلامة والمرافق في منشآتنا الصحية. أستاذ جمال، ممكن تبدأ تعطينا نبذة عن نفسك سريعة ومن ثم ننطلق بإذن الله.
يعطيك العافية يا باشمهندس. كفيت وفيت. الله يعطيك العافية، يعني خجلتني. عبد الله يرضى عليك. طبعا أخوكم جمال الشعار. أنا في مقيم مع السباحة من أواخر 2012 بداية 2013، وكنت مسؤول عن برامج تدريب المقيمين للاف ام اس سورفايرز، مقيمين الاف ام اس، بالاضافه الى الاي اس ار، مقيمين الاي اس ار كلهم كاطباء وغيرهم. واستفدنا بشكل كبير من السباحه، المركز السعودي للاعتماد بالمنشآت الصحيه، ولا الاخوه الزملاء في كل مكان نروح نتعلم من جميع الاخوه. والله يعطيكم العافيه. فان شاء الله نتمنى انه يعني تكون محاضره فيها الفائده للجميع باذن الله تعالى. ونعتذر، انا عارف انه يور ويكند يوم اجازه عندكم، وانتم جالسين في اخر اليوم تستمعوا الى محاضره على الهازمات. ف يعني ان شاء الله انها ما تكون تو بورينج باذن الله تعالى. I'll try my best انها تكون محاضره يعني خفيفة شوي وما تكون مملة عليكم إن شاء الله تعالى.
أستاذ جمال، أنا بكون متابع معك، ما راح أقاطعك إن شاء الله إلا إذا كان في سؤال مهم. ما حيكون تفاعلي لأنه راح تكون لكتشر أو محاضرة، لكن لو وجدت سؤال مهم ممكن أنه أستأذنك بالسؤال. حاول تكون المحاضرة بالعربي، وأيضا إذا قدرت أنه أنت توازن ما بينه وبين الإنجليزي برضو ممتاز، لأنه في عدد من الحضور يتكلم اللغتين منفصلة. شكرا لك.
الله يحفظك. I will try my best إن شاء الله. بحاول إن يكون عربي إنجليزي، ما شو اعذروني أحيانا تكون اللغة الإنجليزية شوي يكون يعني طلعنا في بيئة تتكلم اللغة الإنجليزية أكثر، وحتى لما جيت الدول العربية كنا نتكلم الإنجليزي في المملكة العربية السعودية. أنا 20 سنة وكانت كل تعاملنا في اللغة الإنجليزية، بس يعني أنا بحاول جهري إن شاء الله إنه أتكلم اللغة دي. تمام. طيب حنبدأ إن شاء الله الليرنينج اوبجكتيفز. إيش اللي حنستفيد من هذه المحاضرة إن شاء الله بنهاية اليوم؟ حنتعرف على الهازارد جروب، مجموعات الخطرة أو المخاطر، hazard categories، hazardous material classifications، تصنيف المواد الخطرة، forms and properties of chemicals، أيضا exposure of hazardous materials effects، إيش المشاكل ممكن تحصل لو تعرضنا إلى مواد خطرة، precautions to prevent accidents and illness، إيش ممكن الإجراءات اللي ممكن نتخذها عشان نقلل من الإصابات والحوادث والأمراض. أيضا متى نستخدم safety data sheets أو نشرة السلامة، when to consult or to use safety data sheets، effective handling of chemical release، آلية التعامل السليمة مع الحوادث أو الانسكاب. أيضا حنتعرف، هذا الشيء مهم جدا، الهيراركي اوف كنترول، كيف أنا أقدر أتحكم وأتخلص من المواد الخطرة أو أمنع الحوادث بإذن الله تعالى. أيضا حنتطرق في النهاية على الراديشن هازاردز لو بشكل مبسط، لأنه هذه لو نتكلم عن الراديشن محتاجة بنفسها هي محاضرة عن عدة أيام. آخر شيء principles of radiation protections، how do I protect myself، كيف أنا أحمي نفسي من المواد المشعة أو الإشعاعات. طبعا قبل ما نبدأ المحاضرة حنشوف بعض الانكاونترز وسي some encounters HAZMAT، يعني هذه أرقام بس علشان تنبهنا للمخاطر الموجودة أو the hazards. عندنا 30 million workers exposed to potentially exposed to 650,000 materials annually. فهذا رقم it's a huge number. Talking about 650,000 hazardous materials that people are exposed to it, and there are many fatalities related to that. العديد من الوفيات بسبب التعرض لمواد الخطرة. أيضا عندنا 20,000 incidents of exposure annually that results in work lost in work days. أكثر من 20,000 حالة تعرض لمواد الخطرة ينتج عنها غياب عن العمل أو تغيب عن العمل. طبعا الأوشك تعرف الغياب عن العمل لما الشخص يضطر يأخذ أكثر من 3 أيام غياب عن العمل بسبب الإصابة أو تعرضه إلى أي انسيدنت. أيضا هنشوف فيديو، هذه it's a real incident happened in Abu Dhabi, and similar incident or almost the same incident happened في المملكة العربية السعودية في المنطقة الشرقية أيضا. So it's about a 4-minute video that will help us or make us hopefully pay attention to what is coming up.
February 2009 at Shah Field, a vital link in this chain was broken.
I came to work that morning. I saw my friend Ramesh feeding the birds. The rest of my colleagues were busy in the workshop. No one was expecting the foreman Tariq to call us to help him at the pit.
Hi, good morning, everybody.
The foreman told us to come and finish the small job and we would do the permit later. The team set off without a permit to work in a hazardous area. This was a deadly shortcut. It was to be their last journey. Hydrogen sulfide, commonly known as H2S or rotten egg gas, is invisible, heavier than air, and deadly, even at low concentrations. Ramesh descends into a toxic death trap.
Ramesh was told to go down into the pit and fix the rope that had slipped off the valve. Then I saw him climb up the ladder to the second and third step, and then he fell down. The foreman called out to me, "Stop the pump." I didn't know what was going on. I could see Tariq trying to lift Ramesh up, and within less than a minute, Tariq had collapsed to the ground.
Panic takes over. Kabir rushes down into the pit. Mustafa leaps down the other side, but the men have less than a minute of exposure to H2S before they fall unconscious.
How this has happened, it was a big shock for me.
Every morning as we leave, we need to identify the hazards. And H2S is one of the big monsters that we need on a daily basis to eliminate. If we cannot eliminate it, we need to control. And above all, if we cannot, we need to protect ourselves and protect our employees.
Lesson has been learned from this tragic incident, and we have engaged the whole organization to make sure that we do not face this kind of tragedies again.
طبعا ملخص الفيديو، هذه نفس الانسيدنت حصل كنا في المملكه العربيه السعوديه، وهذا حصل في ابو ظبي. الهيدروجين سلفايد هو غاز معروف من الغازات السامه جدا وغازات يصاب الاشتعال H2S. طبعا يقتل بالاقل من دقيقه لو كانت الكونسنتريشن 100 جزء بالمليون 100 parts per million. That's a very low concentration. It is يعتبر انه قاتل خلال دقيقه واحده. So what happened؟ ليش حصل هذا الحادث؟ طبعا صار في استهتار بسبب تصريح العمل. يقول لك هتاخذ معي only 1 minute، هتاخذ دقيقه واحده عشان انا احد ينزل ويعلق الحبل مكانه. Just it will take only 1 minute to tie the rope in place or to put it back in place. So they just ignored, said, why wait for the work permit? So we can do this and leave. And unfortunately, multiple people died just because of that shortcut. Same incident as we mentioned earlier happened في المملكة بسبب lack of knowledge. People did not know the risk of hazardous material that they are dealing with. Do we have H2S in the kingdom? Yes. Is it popular in hospitals? No. Sometimes you'll find it in a low concentration with the sewage, or in areas where there are oil and sewage. So in the eastern region of the kingdom, yes, you will find it. So, and as we mentioned earlier, you can see that it is H2S is heavier than air, so it goes down. So, and it will sit in these areas where you have any holes or manholes or any lower areas, valleys, and so on. So that's the risk of H2S. So we'll start with definitions to make it a bit easier to understand what is going on. هنبدأ في بعض التعريفات. Hazard. What is the definition of hazard? There are so many definitions. If you open Google, if you check online, or you'll find many definitions. And the easiest definition I was able to come up with or to find is anything that has the potential to cause harm. أي شيء عنده الاحتمالية إنه يسبب ضرر. So what do we mean by harm? Sometimes you might think of only injuries to human. No, that is one third of the answer, or that's one thing of the harm. So could be injuries, إصابات للموظفين أو غيرهم. أيضا pollution to the environment, تلوث للبيئة. أيضا loss of assets, فقدان للممتلكات. على سبيل المثال لو حصل حريق لا قدر الله ممكن ما حد يتأذى ولكن حيسبب ضرر الى الاوزون الى البيئه وبنفس الوقت حيكون في خساره في الممتلكات. So if we have a fire, when we talk about harm, we mean three things: either injuries, or loss of assets, or the pollution to the environment. So whenever we talk about harm, we make sure that we understand the three elements. So the definition of hazard is anything that has the potential to cause harm. Hazardous material. It is similar definition, or that will get us to the definition of hazardous material. So it is a substance, any substance, whether no matter how it looks like or what shape it is in, that can cause harm. And again, that could be physical or health hazards, injuries, and so on. So that is hazardous material. How about hazardous waste? Would that be the same definition as hazardous material? Yes. It is the same definition, except there's one small thing to add to it. Hazardous waste has no value. So if we think so, it is a hazardous substance, that any substance that can cause harm, but it has no value. I cannot sell it, I cannot buy it, so it has no value. But it causes a lot of harm. It has the same danger that hazardous material has. And sometimes it has even more hazards. Some chemicals, if they're exposed to another chemical, they become more harmful. And sometimes with time they change, for example, oxidizers. When exposed to heat, or they're exposed to sunlight, or exposed, or just by sitting too long, they can change into peroxides. And they can have a bigger effect. So بعض المواد الخطرة أو الويست ممكن يكون ضرر أكبر من المواد الخطرة العادية اللي ممكن نستخدمها، لأنه بعض المواد الخطرة لو جلست فترة حتتحول من مواد مؤكسدة إلى مواد أكثر خطورة، أو أحيانا لما تتفاعل مع مواد أخرى ممكن يكون الضرر فيها أكبر. طبعا في الماث لما نعرف إن 2 زائد 2 يساوي 4، لكن في الكيميكال لما نتكلم على هازمات ممكن نقول 2 زائد 2 يساوي 6، أو 0 زائد 2 يساوي 8. فتختلف يعني يمكن doesn't make sense for us. We're talking about when we add two numbers, we say 2 plus 2 equals 4. But in chemicals, when we deal with the hazardous substances, sometimes if I say 2 plus 2, it could be 4, or 2 plus 2 could equal to 6, or sometimes I can say 0 plus 2 equals to 8. So that's if I'm looking at the hazardous material, two hazardous materials. One of them is harmless, like for example, ethanol. Ethanol is, we all know it is flammable, but it's harmless, it's non-toxic. But if I add it to xylene, for example, then there will be a reaction with the enzymes, and it becomes, the toxicity of the xylene becomes 8 times than the normal xylene, even though just I add it with another chemical that is non-toxic. So that's we have to be careful with these chemicals when we mix them, the incompatible chemicals and so on. Then we come to the next definition. It's a boiling point. I did not put all the definitions because there are so many of them, but I tried these where there will be confusion. We have the boiling point and we have the flash point. What is the difference between boiling point and a flash point? So the boiling point is usually is the liquid. That's when a liquid, the pressure of a liquid changes to equal the pressure of the atmosphere. We all know the pressure of the atmosphere is about 14.7 psia, or equivalent to 760 millimeters of mercury. So that's when you boil something, you can see small bubbles start to boil, and it's just coming up to the surface and comes back down. Then you can see it again, just shoots up to the surface, but then it comes back down. Then finally, it just breaks through. That means the pressure had reached the atmosphere pressure or more, so that's when it starts boiling. How about the flash point? So the boiling point was when liquid changed into gas. The flash point is also when any substance changes into gas. It could be a liquid or it could be other liquid. But the difference between the flash point and the boiling point, the flash point when it changes into gas, that can ignite with a mixture of air. So it is flammable or combustible, that is going to have a fire, it will ignite. نقطة الغليان ونقطة الوميض، الفرق بينهم نقطة الغليان هو يكون اختلاف في ضغط السائل إلى أن يكون أكبر من الضغط الجوي، فيبدأ السائل بالغليان. عادة المياه we all know that water boiling point is 100 Celsius degrees. درجة غليان المياه 100 درجة مئوية. The flash point هو لما السائل يتحول إلى غاز قابل للاشتعال. طبعا مع وجود الهواء. These are the two different definitions. I added these definitions because they are similar, but a lot of people confuse the two of them. So it is the minimum temperature at which liquid gives off vapor to form ignitable mixture with air. So flash point, it will ignite, and so a flash point of water is not, because it will not ignite with it does not burn. Hazard communication law. Employer must provide employees with the following. So this is a written hazardous communication program, a list of hazardous materials, safety data sheets, and of course training. And you can see always during Sibahi visit or JCI, they will ask you for that you to have HAZMAT program or HAZMAT plan. And it has to include the minimum. So of course there are other things, elements of the program, but the minimum that has to be written, it has to be updated, and you need to have a list of the hazardous materials and safety data sheets for each HAZMAT, and you have to train all staff dealing with HAZMAT. طبعا السباحي وجوينت كوميشن يطلب انه يكون في عندنا برنامج للتعامل مع المواد الخطر، لازم يكون مكتوب موثق بوليسي او بلان. ايضا يكون في انفنتوري، يكون عندي جرد للمواد الخطره الموجوده، وتراي انه يكون في عندي جزئيه يعني اقلل من هذه المواد الخطره. طبعا نشره السلامه تكون موجوده لكل المواد اللي موجوده في القسم، ممكن تكون الكترونيه، ممكن تكون ورقيه. So it's no problem to have it electronic or to have a hard copies. And you have to train all staff. لازم يكون في تدريب لكل الموظفين يتعاملون مع مواد الخطر. So what is exposure? There are three different types of exposure when we talk about exposure أو التعرض للمواد الخطرة. There is a physical exposure, that's working with chemicals with no ventilations. Environmental exposure, using hazardous substances for extended period of time, and potential exposure hazard related to work patterns, presence of employees with a hazardous area, and presence of hazardous materials. So the physical exposure, that working with chemicals with no ventilation. نشوف هذا الشيء بشكل كبير في المختبرات, especially if there's a histopathology. لما يكون في علم التشريح المرضي في المختبر, الهيستولوجي أو سيتولوجي, حيكون في استخدام لمادة الفورمالدهايد والفورمالين, أيضا مادة الزاينين, الميثانول والإثانول والبيكريك acid, and there are so many different chemicals. So you can see the smell is really bad in that area because you have a large number of formalin. مواد الفورمالدهايد والفورمالين أثقل من الهواء, أيضا تنزل فبتكون رائحتها قوية جدا. أيضا هي من المواد المسرطنة, it's carcinogenic. أيضا environmental exposure, استخدام المواد الخطرة لفترة طويلة, هذه الكرونيك افكت حنتكلم عليها later on. لو أحد يتعرض إلى مواد خطرة لفترة طويلة من الزمن ممكن يصير في إصابة, ولكن لو تعرض لها مرة واحدة زي ما قلنا المسرطنات مثلا الفورمالين أو الفورمالدهايد, لو شخص تعرض لهذه المادة مرة أو مرتين أو 3 مرات في concentration حتى لو كان عالي ما حيصاب في سرطان أو في تحول الجينات. ولكن شخص يستخدم هذه المادة إلى سنوات في concentration أعلى من ال permissible exposure limit فهيصير عنده أكيد يتعرض إلى أمراض مزمنة. أيضا potential exposure المخاطر التعرض لهذه المواد يكون في هذا related work pattern. شخص زي ما قلنا يتعرض لهذه المواد بشكل يومي، يدخل مختبر مثلا الساعة 8 إلى الساعة 10 اللي يكون فيها تعرض للفورمالين أو يتعرض إلى الزاينين إلى فترات طويلة، فهذه حتسبب إصابات. The groups of hazards مجموعات الهازارد. It's always easier when I'm looking for a hazard or I'm doing risk assessment or تقييم المخاطر. So it's much easier for me to know the groups. There are 6 different groups in general to identify hazards, but when it comes to hazardous material, we have it just lowered down to 4 groups, or I linked the 4 groups that are related: physical, chemical group, biological group, environmental group. So these are the 4 that are related to hazardous material. The other 2, we have mechanical group, we have psychological groups. These are in a way not really related much into HAZMAT. So what is a physical group, and why is it physical group? Why did I include that in HAZMAT? Of course, the physical group, that's if we look at it in general, physical group covers the fires, covers explosions, covers slip, trip, and fall, falling from heights, hit by an object, falling into a pit, and so on. So it's a very wide range. So since we're talking about fires and explosions, and these are usually caused by hazardous material, so it is part of that group. Also, chemical groups, that's of course it's logic. Biological groups, when we talk about hazard or hazardous substance or hazardous materials, we don't forget the biological, the effect of viruses, bacteria, fungus, and so on. We will talk about that in more detail. And of course, environmental groups, and we have our effect on the environment. As we mentioned earlier, that harm could be effect in or pollution to the environment. Also, here we look at it from a different perspective. So we have both ways: our effect on the environment, تأثيرنا احنا على البيئة, and the effect on the environment on us, أو تأثير البيئة علينا, which is we have the radiations, the ultraviolet radiation from the sun that can cause cancer or can cause burns, and we have many other hazards that are in the environment, dust and so on. And these are all considered because they carry parasites and viruses and bacteria, and they help in spreading that infections. So if I'm looking for a hazard, always try to remember the categories. So if there's a saying I read once and I liked it, and I always use it, that said, if you don't know what you're looking for, you'll never find it. So sometimes we're going crazy trying to look for something, and someone asks you, "What are you looking for?" I don't know. So you're lost. You will not be able to find what you're looking for. So here you remember probably someone's taken the NEBOSH. Of course, you remember the ME, MEEE, or sometimes they call it the MEEP, MEEP. And that stands for the materials, equipment, environment, and employees. So if I'm looking for a hazard, if I need to identify hazards, so I need to search with these 4 categories to be able to have a complete coverage. So materials والمواد المستخدمة. So هذه حتساعدني في identifying الهازارد، إنه أشوف المخاطر الموجودة. المواد المستخدمة نفسها، هل فيها مواد خطرة؟ هل فيها مخاطر؟ أيضا المعدات اللي يستخدمها، هل أيضا فيها مخاطر؟ ممكن نقول equipment. What kind of hazards would I have in equipment؟ المعدات الطبية والمعدات اللي ممكن نستخدمها في الأقسام، هل فيها مخاطر؟ نعم فيها مخاطر. وحصل انسيدنت عدة سنوات، جهاز بيع في الماركت، أحد المستشفيات تخلص من جهاز، ولكن هذا الجهاز كان في source of radioactive materials. source صغير بحجم يمكن ربع الإصبع الصغير. Very small part that has a radioactive source, and that radioactive materials for like uranium, for example, it would last hundreds of thousands of years. So, and multiple people died because people tried to dismantle that machine and or that equipment to sell it in spare parts, and they had no clue what they are facing or what they might be facing. So they were exposed to high dose of radioactive materials, and multiple people died. And of course, the equipment went from one country to different country to different countries, and that made it much worse exposure, unfortunately. That's why in the في المملكة there's a very high or very strict process when you have to deal with any radioactive materials or radiation. كل المعدات اللي فيها مواد مشعة أو الأشعة لها process، لها إجراءات خاصة very lengthy، تتضمن البوليس، تتضمن هيئة الغذاء والدواء، مدينة الملك عبد الله للطاقة للذرة والطاقة المتجددة، ومدينة الملك عبد العزيز، and so on. So it's a very lengthy process just to avoid these risks. أيضا the environment. When we talk here about environment أو نتكلم عن البيئة، نتكلم for both the environment outside the workplace and the workplace environment itself. If I'm working in one area, I don't have ventilation and I have chemicals, so that means many people will be exposed. So that will affect. If I have an area that is too cold or that's too hot, so would that affect the hazardous material? Yes, of course. If I'm dealing with an area where it's too warm, that means my chemicals will have the evaporation, and it will be more. As we mentioned earlier, the flash point. So if I have chemical with a lower flash point, that means it's already changing into gas that can ignite because of the heat. Also, when the weather is too cold, it will affect our respirators, the valve, so that the fit won't be as good. So then we'll have a leak of hazardous materials, and people will be affected. And of course, the employees. So can employees be hazardous? What do you think? Yes, of course. So the first three that we mentioned, the environment, equipment, and materials, these are conditions or states of being. So, and the employees, these are behavior. So anything that depends or has to do with behavior, we're going to have much higher risk of accidents. So even though when there's some studies showing or to find out the accidents are related to conditions or behavior, they found that 95% of accidents are related to behavior, as we just saw in the video earlier. So they just did not wait. They didn't want to wait 15 minutes for the work permit to come in or to do the work permit, and multiple people died just because they took a shortcut. So السلوك طبعا نتكلم هنا عن السلوك او الكونديشن اللي هو لها علاقه بالمعدات والمواد والبيئه. هذه لها علاقه فقط في 3% من الحوادث، و95% من الحوادث له علاقه بالسلوك، السلوك الخاطئ. طبعا نتكلم انه الناس تاخذ شورت كت، ما يتبع سياسات، وكلنا نمر بهذا الشيء. احيانا تكون بالليل as you're driving at night you get to a traffic light and there's no sahir in that traffic light, and you look around, no one's around, I don't see any police, so you cross that red light. So I'm not going to wait 2 minutes on that traffic light. But if there's a sahir, then nobody will cross that. You will just sit even if you have to wait for half an hour. فالbehavior السلوك مشكلة، وهو من المسببات الأساسية للمخاطر. نتكلم لو كان في إشارة مرور، واحنا واحد بالليل يسوق وتعبان يبغى يوصل البيت ويشوف الإشارة لونها أحمر وما في ساهر عليها، ولا يشوف هنا ما في أحد يجي من الطرف الآخر، يقطع الإشارة ويروح البيت. كلنا نمر بهذا الشيء، أحيانا نسوي مع الأسف. ولكن لو في ساهر على هذه الإشارة أو يشوف بوليس واقف، حنتظر. حتى لو انتظرت نص ساعة الإشارة، أنا I'm willing to wait. So behavior is, if we control behaviors or make safety as a culture, we'll reduce a lot of the accidents. Something I came up with during the studies, and to make it easier to understand, I called it the accident equation. So accidents happen because we have, of course, we have hazards, regardless of what type of hazard, whether it could be hazardous material, or it could be any other hazard. So the room that you're sitting in right now, every one of us, we're sitting in a room. I'm very sure you have electricity. And we all know that electricity is a hazard. So how come no accidents are happening? No one's getting injured. No one's getting electric shock, even though we have hazard. And electricity is considered as a very major or a big hazard. Why? Because we don't have exposure to that hazard. So when you have hazard, we have hazards everywhere. whether in our homes, on the roads, in our workplace. So hazardous substances are available everywhere. But if we don't get exposed to these hazards, we will not have accidents. We will not suffer any injuries. So إذا المواد الخطرة موجودة وإذا ما تعرضنا لها ما هيصير في عندي إصابة. هنتكلم على الروت اوف انتري، كيف آلية دخول هذه المواد الخطرة إلى جسم الإنسان. طبعا برضه المواد الخطرة إذا ما دخلت إلى جسم الإنسان ما هيصير في إصابة ولا هيكون في أي أضرار. فهذه المعادلة مهمة جدا. This equation is extremely important. Try to use it, guys, and try to think of it whenever you're doing hazard analysis. Try to think of the hazards and try to think of the exposure. How could people be exposed to that hazard? So hazardous material classifications. Of course, we have the biological. That's what we'll cover in this course, inshallah. Biological hazards, chemical hazards, and radiation or radioactive materials. Of course, in brief, we're not going to go into details. If we need to cover this in details, you're going to be listening to me for 3 days, at least. So biological hazards, we all probably know, especially in a healthcare setting. That's what makes a hospital or healthcare settings more risky than other workplaces for the most part, because, or more different, I can say, to other workplaces, because we have a lot of biological hazards. So, and they say that's, riding on a plane, we all know that it's very risky, right? And some people are even afraid to ride on a plane. But there's a study showed that going into a hospital, walking into a hospital is 1,000 times more risky than riding on a plane. So the risk is extremely high when going to the hospital because of these biological hazards. So biological hazards, and you can see it as we mentioned earlier, between the waste and the hazard, they're almost exactly the same thing. But waste sometimes it's more hazard. الويست ممكن يكون المخاطر تكون أعلى وفي some cases حتكون أقل ولكن ما لها قيمة. But that's what makes it even more difficult. People ignore it because it has no value. Again, worldwide, around 320,000 workers die each year from chemical diseases and caused by workplace biological hazard. 320,000 شخص اللي يموتون في كل سنة بسبب تعرضهم إلى الأمراض المعدية أو البكتيريا وفيروسات هيباتيتس بي، هيباتيتس سي، HIV, tuberculosis, COVID-19, and so on. So when we talk about biological hazards, as we mentioned, we talk about viruses and bacteria, الفيروسات والجراثيم الضارة, toxins from biological sources, المواد السامة اللي تنتج عن المواد الخطرة أو الفيروسات والبكتيريا, spores, even fungus, and pathogenic microorganisms, and the lastly is animals and insects. And a lot of times we forget this. We can say, what does animals have to do with biological hazards? So if we look at the definition of hazard, again, that is anything that has the potential to cause harm. أي شيء عنده قدرة أن يسبب ضرر. Animals, of course, because they transmit multiple diseases. We all know that mosquitoes, they transmit West Nile virus. They transmit different malaria. They transmit a lot of other illnesses. And same thing with animals. So rats and mice. Sometimes they bite someone, or they go and transmit. They can transmit diseases like plague and others. Then for viruses and bacteria, which one is bigger? Is it a virus is bigger than a bacteria, or bacteria is bigger? And which one is more dangerous? So we can say it can transmit easier than others. So of course, you probably already know that is the answer. So it really depends on the transmission mode, and it's the highest risk of pathogens are the airborne pathogens that they transmit through air, because people can cough, people as they're talking, they're sneezing, they will transmit that bacteria. Usually bacteria, they're much larger in size, and they can just go or be suspended in the air for a long period of time, and then someone comes and inhale them. But viruses, sometimes, or droplet-borne, blood-borne, they will be transmitted slightly differently, and we'll talk about that in more details. So we have blood-borne pathogens, And we have airborne pathogens. Bloodborne pathogens that are the pathogens that they transmit through either human blood or blood products. So it's basically from humans. So you have to be close, one person close to another person for that infection or for the pathogen to transmit. Some of them, if you have like a cut of, so if some blood gets on my skin, someone who has HIV, for example, I have a patient, I'm doing something, he shakes my hand, and I notice that he had a cut on his hand, and the blood gets in my hand. And I know he's an HIV positive. So will I get an infection? What do you think, guys? Maybe, maybe not. What if someone has hepatitis B? In the same condition, but someone has hepatitis B. وبعد فيروس الكبد B. Would I get the same rate, the same chance of getting an infection? No. So if someone has HIV virus, somehow nothing will happen. Because it will not penetrate your skin unless you have a cut. So when there's a cut, then there's a virus that might have a chance of penetrating into your bloodstream, or it goes through the membranes like the eyes or the nose or the mouth. But for the what percentage, try to write it down. I know you can't talk to me, but try to write it down, see how close you are to the answer. So someone who gets, their blood gets matches or gets inside another person's blood, small quantity who has HIV. What is the percentage of this person getting HIV? That I know that the virus already get into this person's bloodstream through an injection or by mistake or through a cut. So if you wrote that 20%, you're wrong. If you said 80%, you're wrong. If you said 1%, you are wrong. It's only 0.1%. So 1 in 1,000 people who get exposed to HIV virus will get the infection, or they will get the virus, because our the immune system will fight it, and it is a very weak virus. So outside the human body, the HIV is a very weak virus. It can live only for a couple of hours on the environment. So, HIV ما يعيش خارج الجسم إلا ممكن ساعتين أو أقل حسب الجو. لو كان جو حار ممكن يكون أقل من ساعتين بعدين يموت، ما يقدر يقاوم خارج جسم الإنسان. لو شخص تعرض إلى دم من شخص آخر مصاب في مرض الإيدز، نسبة 1 في 1000 إنه ينتقل المرض إلى هذا الإنسان بسبب المناعة. طبعا في فاكتورز، شخص عنده مناعة قليلة إنما يكون الريسك أعلى. ولكن hepatitis B, as we mentioned earlier, ممكن تكون النسبة إلى 60% لأنه الفيروس أقوى بكثير. طب كم يعيش خارج جسم الإنسان؟ hepatitis B ولا hepatitis C? How long does hepatitis B and hepatitis C live outside the human body? Write that down and see how close you are to the answer. If you wrote 50% or 60%, I'm sorry, the days. So if you wrote 2 hours as HIV, you're wrong, because it's a much stronger virus. It could live up to 7 days, and some studies showed up to 15 days. So hepatitis B and hepatitis C can live up to 2 weeks on a dry surface or outside the human body, and that's what makes them more dangerous than HIV virus. So if you go into a hospital, you touch any surface, who knows what that surface, you cannot see anything. It does not have to be blood. Remember, say blood or blood, it could be mucous membranes, could be urine, could be someone sneeze, or so the viruses are there or the bacteria is there. So if you touch a surface that has the virus, now the virus is in your hand. So if you wash your hands, you're fine. The virus is dead or the bacteria is dead. If you use the hand sanitizers for the proper way, then the virus is dead. You will not get any injuries. So this is very important. But if you don't, and you go and eat or touch your eyes, touch your nose, then you can transmit that virus or bacteria could go into your bloodstream. Airborne pathogens, they are a lot riskier, or they're much more hazardous because they transmit through air. So someone has tuberculosis or any other illness that transmits through air. So when they cough or sneeze or they even talk, that tuberculosis, for example, the bacteria, they're very tiny, they're suspended in the air for a long period of time. and they are alive. Someone can breathe, and they can get into inside the lungs, and they can affect the person. So inside our lungs, we all know that the lungs, they are small. It's called alveoli. حجيرات صغيرة هي اللي يتم فيها تبادل ثاني أكسيد الكربون مع الأكسجين. الإنسان يتنفس الهواء، ياخذ هواء نظيف في نسبة أكسجين تقريبا 21%، وفي الرئتين يتم تبديل من الدم من ثاني أكسيد الكربون مع الأكسجين، فيطرح الإنسان لما يتنفس أثناء الزفير يطرح ثاني أكسيد الكربون وهياخذ أكسجين. So when we are breathing through these alveoli, there will be exchange of the blood of CO2 with carbon dioxide. So when we breathe in oxygen, almost 21% in the air, then we breathe out, there will be still oxygen, around 16% in the air that we breathe out. But inside these alveoli, why I'm trying to get to this, inside these alveoli, they're extremely tiny, and that's the bacteria gets there, and it can grow because you have perfect environment. You have oxygen, you have moisture and the mucus, and these are perfect environment for the bacteria. We're going to talk about another hazardous substance. It is considered as an airborne, which is it is not a bacteria. The asbestos. So it looks like a small hook, like a fishing hook, and it goes inside the lungs, and it causes a scar. It will not be removed. So once it gets there, it's just stuck there to the lungs. And what happens when you cut your hand, or any scar, any cut in your hand or your body? Then when it heals, you'll have a scar. It's a thicker tissue than the normal skin, and that's exactly what happens inside the lungs. So from this small scar, it becomes thicker, it becomes more difficult for air exchange. So it becomes more difficult for a person to breathe. Then it will change into lung cancer, it's a mesothelioma. So that's one type of exposure to hazardous substance, which is the asbestos. So how many alveoli do we have inside our lungs? Just try to show how small these alveoli are. هذه الحجيرات الصغيرة في داخل الرئتين. تكلمنا على الاسبستوس، لو دخل إلى الرئتين، هذه هي من المواد الخطرة أو المواد المسرطنة. ممكن تسبب بشكلها يشبه لوحة يصيد سمك، الهوك اللي تكون نعلقها فيها الطعم علشان نصيد السمك. لو تدخل في الرئتين ممكن تسبب جرح في الرئتين، عشان الجرح هذا يشفى يصير فيه سكار، يصير فيه ندبة. الندبة هذه تكون سميكة، ما يتم تبادل الأكسجين مع ثاني أكسيد الكربون بسهولة، فبالسبب يصير في ضيق في التنفس، وبنفس الوقت يصير في تتحول إلى سرطان الرئة اللي هو ميزوثيليوما. هذه المواد الخطرة. عدد هذه الحجيرات الصغيرة أو these small alveoli, there are around 700 million alveoli inside our lungs. So you can imagine how tiny they are. 700 million inside our lungs, which they're very small in size. Very small in size. So it's a huge space. And that means we're talking about this not only one for bacteria. When it comes in your body, it's not one or not two or not 100. It comes into millions of bacteria. Transmission mode, as we mentioned.
أستاذ جمال، الله يعطيك العافية. طبعا احنا نعتذر بصراحة لأنه واجهنا مشكلة، عدد المسجلين قرابة 500، والمقبول الآن بالقاعة الافتراضية هم 100 شخص فقط. فالمحاضرة مسجلة وإحنا بلغنا الجميع بإذن الله، يعني للأشخاص اللي ما حالفهم الحظ أن يكونوا من هال100 يعني الموجودين حاليا. فهذا خلل فني، ولكن يجري الآن تدارك إن شاء الله، والمحاضرة مسجلة بإذن الله، راح تشارك للأشخاص اللي برا القاعة. وتفضل أستاذ جمال.
الله يعطيك العافية. هذا يدل على حرص للأخوة، الله يعطيهم العافية ويجزاهم الخير. فهذا الحرص الجميل، نشوف الإنسان عنده الحب للعلم. وأنا دائما يكون
والله الجميع يتواصل الآن من كافة القنوات، يعني رغبة الحضور، ولكن سبحان الله لعل ما حالفهم الحظ، فإن شاء الله نتداركها بالمرات القادمة. تفضل أستاذ.
شكرا. Okay, so the transmission mode. And we said we have a direct or indirect transmission, and which we covered very much for the most part. So النقل التنقل غير مباشر والمباشر. direct contact شخص يلمس شخص آخر، سلام، يسلم عليه، يلمسه، أو أحيانا الطفل مع الأب أو يعني يكون في تواصل، فممكن ينقل المرض من شخص إلى آخر. So direct contact from person to person, when you shake hands, when you kiss someone, you know, whether it's your son, your daughter, your grandson, if you are infected, you could transmit that infection to him. Also, we have a droplet transmission, which is droplets. It's similar to direct transmission, and that's what for the COVID-19. Of course, we know the COVID-19 virus. It was classified as a droplet transmission, not airborne. But of course, the MOH said, just to protect more people, said let's consider it as an airborne transmission to have higher restriction to prevent the spread. And one of the best countries that were able to control the COVID-19 was the Kingdom of Saudi Arabia. المملكة العربية السعودية جزاهم الله خير في الجهود اللي بذلت، كانت من أفضل الدول اللي تعاملت مع الكوفيد 19 بسبب طبعا السي دي سي أعلنت إنه الكوفيد 19 هو دروبلت بورن، ولكن يعامل كأنه ايربورن، ينتقل عن طريق الهواء. طيب الفرق بين الدروبلت بورن والايربورن؟ الدروبلت بورن ممكن ينتقل عن طريق الجو لمدة مسافة متر، مش أكثر من متر، لأنه الفيروس أو البكتيريا تكون معلقة على الدروبلتس، الجزيئات الصغيرة هذه اللي ممكن تترافل حوالي متر وبعدين تطيح على الأرض. ولكن الايربورن راح يكون معلق في الهواء suspended for a longer period of time. Indirect transmission, we have airborne transmission. As we said, someone coughs, then the virus or the bacteria is suspended in the air. Someone else comes breathe in or gets in their hand or through their lungs, and we will see later on the highest area or the highest way of transmission of these infections or the routes of entry is through inhalation. We will cover that in a few more minutes. So airborne transmissions, dust or droplets, nuclei suspended in the air. So the bacterial virus will be suspended in the air, either laying on a small dust droplet or anything. Then we have the vehicle-borne. So that means you need something to transmit that disease, to carry that virus or the pathogens. So that's why I call it a vehicle-borne, because they need a vehicle, they need something to transport it. And that's usually, it could be through the water, it could be through the foods, vegetables, especially things that we don't cook, the raw food and vegetables. Or it could be the instrument in the hospital, that someone during operations, doing an operation or anything that is infected instrument, it can cause the cross-contamination. Or even the linen itself, you have it will transmit some diseases that we use in hospitals or use at hotels or use at home or use anywhere. So these are vehicle-borne. And of course we have the vector-borne, and these are what we mentioned earlier through insects, like you have the ticks or fleas or mosquitoes and bugs. So all these they transmit different illness, different diseases. The ticks transmit. We don't see it much, or it's not popular in the kingdom, but it's in the States. It is very popular, the deer tick and other types of ticks that transmit the Lyme disease, which can change into cancer. And the mosquitoes, when the mosquito bites you or they sting you, they bite, but you don't feel their bite. And why we don't feel that? SubhanAllah, because even though they are very small, they're very tiny, but they have a gland that they will put some materials on your skin, some liquid in the skin to make it the khadra, to make it numb, so that you don't feel it. And you can see in this picture, they have a small, very tiny tube, so they cannot suck your blood. When they try to suck the blood, they can't, because our blood is too thick for them. So they have to inject in our skin or in the bloodstream. They have to inject a blood thinner. It's like we have in the medication, people who have heart diseases and stuff, heart attacks, they give them aspirin or warfarin or these blood thinner medications to make the blood a little bit thinner so it will flow easier. And that's what this mosquito does. So when they inject that material or the blood thinner liquid into your bloodstream, they inject with it sometimes bacteria or viruses that are already, they had the infection or they were infected. And some, they inject the eggs, like the sandfly, for example. And that is available in the eastern region. We've seen that in many cases. We had at our hospital more than 20 at a certain period of time. We had more than 20 people exposed to sandfly, where they will inject the same thing. They will inject the that small eggs under the skin, and the life cycle will start. These eggs will hatch into larvae. The larvae will start to eat the skin, the subcutaneous layer or the underlayer of the skin, until the complete cycle. By the time that finish the complete cycle, there will be a very big damage to the skin. تشوهات شديدة للإنسان. So that's how they carry, or we get the cross contamination or the infection. And of course, the fleas, they carry different illness, like the plague. For example, flies, they carry the Shigella, for example, because they come in many times. If you look at the flies, you see they are rubbing their back legs. If you notice closely, if you look at them closely, you see they're standing over food or any area and they rub their back. They're cleaning themselves. So when they rub their legs, any insects or any bacteria or eggs of different pathogens will drop into the food, and that's how they carry these parasites or these pathogens. So I'm going a bit fast just to make sure that we cover the more. And this part now, chemicals, it is the largest part because we have a lot of chemicals everywhere. We have substances, and we'll cover briefly the medical gases because I know the guys, Jazakumullah khair, there will be another lecture about medical gases. So I'll focus mainly about the hazards in the medical gases. So chemicals or hazardous substances, they are everywhere in our home or in our hospitals, in the roads, everywhere we go, there are chemicals. So the chemical forms, we all know since we were young, we learned that chemicals comes in 3 forms. أو شكل المواد الكيميائية بتيجي في 3 أشكال، ممكن مادة سائلة أو المادة الصلبة أو 3 حالات، الحالة الغازية. So liquid, solid, and gas. So we all know that. But to think of it from a safety point of view, we'll try to break it down more. For example, the solid. The solid, I can break it down into the solid. I have big pieces of, let's say, rock, for example. If I grind it, it will give me crystals or granules. It's like the salt that we have at home. الملح الصخري أو الملح البحري، تشوفوا إنه جزيئات صغيرة هي الجرانيولز. أيضا, if I grind it even more, it will change into powder. Something that is fine. الملح العادي اللي نشوفه ملح الطعام هذا more of a powder. But if I grind it even more, if I tap it, grind it more, what does it change into? Something much smaller particles. What do we call them? We call them dust. Okay. So the solid could be bigger pieces, could be granules or crystals, it could be powder, or it could be dust. So that is very important when it comes to safety. Why is it important? Because of the shape, because of the transmission, how it gets into our body. Remember, we said inhalation is the highest part. If you're at home, you like to cook, and you're trying to make a cake, and you drop the baking soda or baking powder, for example, fine dust, really fine dust. You drop that, and the bag breaks, and you see that baking soda just suspended in the air. It's just gonna go in the kitchen floor and in the kitchen air. It's gonna be suspended for quite a long time. And sometimes you don't see it clearly, but if you have a window and the sun is shining through that window, you can see through the rays, you can see the particles suspended in the air for a long period of time. And if you drop the same thing, if you drop the salt, the sea salt, which is big granules, and it breaks, it's just going to be laying on the floor. It will not be suspended in the air. So what difference does it make? So why is that as significant? ايش الفرق؟ لو الملح الصخري انسكب على الارض حيكون على الارض، مش حيتطاير في كل مكان. النشا او البيكنج باودر، مواد الدست هي صغيرة جدا، حط طائر في كل مكان وتبقى معلقة في الجو إلى فترة طويلة من الزمن. طبعا لو كانت هذه مادة سامة على سبيل المثال، وأحد زملائك يشتغل في المختبر ويشتغل في هذه المادة اللي هي الدست، وشفته إنه مغمى عليه في المختبر وهذه المادة متطايرة في كل مكان، تشوف الباودر الدست suspended في in the air. Would you go and help him even though he's your best friend? No, of course not. We saw what happened in the H2S. So 3 people went to help and 3 people were injured or died. So if you go try to help him, if you don't have the right PPEs, you're going to be a second victim. What if it's instead of that dust, that was crystals or the granules? So someone, same thing, is your friend and you like him so much and you care about him, and he's unconscious on the floor, and you see that solids everywhere around him on the floor. Yeah, of course you can go, because if you wear gloves, that would be enough to get him out safely, because it's not everywhere. You cannot breathe it because it is the particles that are sitting on the ground. Same thing with liquids. So liquids can come in different forms. So we have the mist, or we have the vapor also. So what's the difference between mist and a vapor? The mist is a very small particles, the droplets of water. So when you pressurize, for example, if we take water, for example, if you pressurize it so much, and then you let it go through a very tiny hole, you will have that mist, that vapor. You see it في الحرمين برا في موجودة، هتشوف المراوح عليها هذا المست الرذاذ اللي يطلع to cool people down. So the mist is whatever the chemical is. If it's corrosive, you're going to have corrosive mist. If it's just water, you're going to have just cool mist. But the vapor, when do we get vapor? بخار. When we have, as we mentioned earlier, you remember the boiling point. So when that water or that liquid changes into vapor, when it boils, so that means it's very hot. If it was water, the boiling point is 100 Celsius degrees. That means that temperature of that steam or that vapor is at least 100 Celsius degrees. And sometimes you use steam, you pressurize it, and it would reach 120 Celsius degrees. So now we have two hazards: the hazard of the chemical itself, and the hazard of the temperature, that water. So it is you have a double hazard. So water, we all know it's non-hazardous for the most part. So it's not considered as a hazardous substance, but when it's steam, it will be considered as hazardous substance because it can cause severe burn, escalate. So المياه هي طبعا نعرف المياه ما هي مادة خطرة ونشربها ونستخدمها في كل يوم، وخلقنا من الماء كل شيء حي. We cannot live without the water. ولكن لو تعرضت إلى درجة حرارة عالية، ستيمر موجود عندنا في المستشفى، البويلرز فيها درجة حرارة توصل إلى 120، تستخدم لقتل البكتيريا والفيروسات والتعقيم. قسم كبير من قسم التعقيم CSSD والتعقيم تعتمد على الأوتوكليفز اللي هو درجة مياه عالية، الضغط والحرارة، فتقتل كل الجراثيم والبكتيريا. فالمياه نفسها أصبحت مادة خطرة لو تعرضت للحرارة. So liquid could be vapor, could be mist. طيب الغاز في عندنا هو حالتين، ممكن يكون في فيبر وممكن يكون فيوم، لأنه هو الآن أصبح مادة غازية. طيب إيش الفرق بين الفيبر والفيوم؟ هذا دائما يكون في ميكس في هذا الترم. كثير من العالم يخلط هذه الكلمتين في بعض، هي اللي يقول لك الفيبر والفيوم هم مختلفين، في فرق كبير بين الفيبر وبين الفيوم. الفيوم الفيبر طبعا هنا شغلنا طبعا من مادة سائلة، لما تحول إلى بخار تعطيني الفيبر. لكن الفيوم هي عادة مادة صلبة، الحديد، دائما نتكلم على الولدنج فيوم، هذه مادة صلبة لما أعرضها إلى حرارة أثناء الولدنج تتحول إلى غاز اللي هو الفيوم. هذا الفرق بينهم. الفرق الرئيسي طبعا واحدة الفيبر يتحول من بخار إلى يتحول من مادة سائلة إلى بخار أو إلى غاز، والفيوم يتحول من مادة صلبة إلى مادة غازية أو بخار، واللي تسمى السبليميشن. ما يمر في المادة في الحالة السائلة، تحول على طول من مادة صلبة إلى مادة غازية. في مع سبيل المثال البخور نستخدمه في كل مكان، في المنزل طبعا، في المستشفى ممنوع يستخدم، لكن في المنزل نستخدمه، هو يتحول من مادة صلبة إلى مادة غازية. نفس الشيء أثناء الاحتراق تشوف الدخان اللي يطلع هذا أيضا هو فيوم من الاحتراق، لأنه ما يتحول إلى مادة سائلة، والمادة صلبة يتحول على طول إلى مادة غازية. أيضا الفرق الآخر الليكويدز أو الفيبر هم مولكيول، بينما الفيوم هو particles. So the vapor is a molecule and the fume is particles. Which one is bigger? You're right. You're absolutely right. So you know the fume is much larger, and you can start it with a piece of paper. But the molecules, they could be even smaller than the oxygen molecule, some molecules. So you can't stop it with a piece of paper. That's why, so when you have something that's smaller than oxygen, if you try to stop it with some kind of barrier, so you'll be stopping the oxygen also. So how do we protect ourselves from these toxic or from these hazardous vapors? That's why we use the respirators or the cartridges. So sometimes you have the face shield or respirator with the cartridges, and these will either absorb the hazardous substance or they will neutralize it. So there are different ways, and they are different for each chemical. Organics, you have a different cartridge. For solvent, you have a different cartridge. For other substances, so you need to make sure that the cartridge or the respirator you're buying that is suitable with the hazard that you have. And there is no such cartridge that's good for all substances or for all hazards. So you have to replace. There are many different types. They go by color code. They're black, orange, yellow, white. They're different colors based on the hazard that they cause. I hope that is clear, because this is an important part. Chemical properties, خصائص المواد, and that is what this is extremely important. هذه مهمة جدا لأنه هي this, if we understand the chemical properties, we understand how chemicals will injure us. We know what are the hazards and how we can prevent it. So hazardous substances, we have, or the property, we have flammability and combustibility. So when we say a flammable material or substance or combustible substance, what is the difference? We always say also these two terms, we hear them a lot, and we mix these two terms, but there is a big difference in what is a combustible material and what is a flammable material. Write it down, see if you are right. And it has to do with a flashpoint. So I'll give you a hint. Flammable materials has the flash point of 100 Fahrenheit, 37.8 Fahrenheit or less. So any substance that has flash point درجة مميت أقل من 100 فahrenheit أو 37.8 Celsius degrees, this is considered as a flammable material. And combustible materials has higher than, the flash point is more than 100 Fahrenheit or more than 37.8 Fahrenheit. So that means flammable will ignite or will burn much, much faster than combustible materials. An example I always give, that if you have a cigarette, a lit cigarette, and you dip it very quick, very fast in a cup that has diesel in it, what happens? So we all know the three elements of fire, مثلث الحريق, ثلاث عناصر اللي هو الأكسجين والمواد قابلة للاشتعال, fuel and heat source, مصدر حرارة. وقلنا لو معي سيجارة ودخلتها بشكل سريع في داخل كوب في ديزل, إيش اللي حيحصل؟ Nothing. Nothing will happen. Why? Even though I have the heat source, which is the cigarette, I have the oxygen in the air, we have 21% oxygen, and I have the fuel, مادة قابلة للاشتعال, or combustible material, which is diesel, because the flash point of diesel is more than 100 Fahrenheit, so it is a combustible, it's not a flammable. So why did it not ignite? Okay, before we answer this, I'll ask you another question. If I tell you that a flammable liquid will not burn, هل هذه جملة صحيحة? Is that a true statement? Flammable liquid will not burn. المادة القابلة للاشتعال, السائل, إذا أقول لك سائل قابل للاشتعال لا يحترق أو لا يشتعل, هل هذه جملة صحيحة? True or false? It is true, because it will not burn as a liquid, it has to change into gas before it burns. Nothing will burn as a liquid or as a solid. It has to change into gas. That's why when you try to light a piece of paper, so sometimes you need to hold the the lighter or the match underneath it for a longer period of time until it starts to change into gas that can ignite. So the flash point is has a higher flash point. So higher flash point, that means it's lower risk because it will not burn so easily. So we'll go back to the cigarette. So if I dip it really fast, I did not allow that diesel, to change this liquid, the diesel, to change into gas at the surface because I went too fast. But if I dip it really slowly, so before it touches the surface, it is giving chance for the diesel to change into gas, and it will ignite. How about instead of the diesel, if I had acetone? Acetone is a flammable, is a highly flammable. So if I dip the cigarette with that, what happens? If I do the same scenario, I have the cigarette, I have a cup of acetone, and I dip the cigarette really, really, really fast. What happens? I probably will not have even time to dip the cigarette. Before it reaches the acetone, it's going to ignite because the flash point is really low. So at room temperature, it is already changing into gas, and it is just flying above the surface. So by the minute it touches that concentration, it is going to ignite. So flammable has a flash point of 100 or less. Combustible materials has flash point of more than 100 Fahrenheit or more than 100 Fahrenheit. Highly hazardous substances, or the properties, then we have the oxidizers, corrosive, toxic, explosive, reactive. So these are the properties of chemicals. And if I understand these properties, I should be able to protect myself. I should be able to avoid a lot of accidents. خصائص المادة المواد الخطرة، المواد الكيميائية، هي المواد قابلة للاشتعال، قابلية للاشتعال، الأوكسيدايزرز، المواد المؤكسدة، الكروسيف، المواد الحارقة أو الآكلة، عندي التوكسيك، المواد السامة، اكسبلوسيف، مواد قابلة للانفجار، والرياكتيفيتي، المواد المتفاعلة، تتفاعل مع المياه وتتفاعل مع الأكسجين في الجو. فهي عدد كبير من هذه المواد. So the more I understand about these properties, the better chance I have to protect myself. For example, oxidizers. What is oxidizer? هي مواد تساعدني في إنتاج الأكسجين أثناء الاحتراق. تعطي الأكسجين. في بعض المواد it will react with itself, and they are very unstable. So they are considered as unstable chemicals because they change from oxidizer to peroxides. Do we have any oxidizers at the hospital setting? Yeah, of course we do. We have many of them. And a lot of common mistake, people sometimes label them as flammable. For example, the main element in a hospital setting is the oxygen, the nitrous oxide. So both of these are oxidizers. In the lab, you have the picric acid, and you have the many others, sodium hydroxide and stuff. All of these are oxidizers. So, and they are unstable. So some of them, they are unstable with heat reactive. So when they're exposed to heat, they will change form and become explosive. Or some of them, they will react just with the light, like silver nitrate. If you leave it a long time exposed to the light, it will change into explosives. Picric acid in the lab, if you have it, so it changes with time. If you don't add humidity to it, if you don't add water, it will change into peroxides. It will crystallize. So enough, then it becomes either somewhat heat sensitive or shock sensitive or friction sensitive. So picric acid, if it changes into peroxides or crystallize, usually you see small tiny crystals around the cap from the inside of the bottle. So if you try to open it, that small friction is enough to cause an explosion. Or if you drop the bottle or the container, it can explode because it is friction sensitive and it is shock sensitive. So oxidizers are very high risk in the workplace. So you have to be careful with them. They don't burn on their own, but they will accelerate fires. If there's a fire, the oxidizer will make it accelerate much faster. So oxygen will not burn on its own, but if there is a fire, it will feed that fire. It will make the fire grow much bigger. من المواد المؤكسدة بنفسها ما تحترق، ما هي غير قابلة للاشتعال، ولكن تساعد. لازم يكون في احتراق موجود، وبعدين هي it will take over، حتساعد الاحتراق وتخليه أكبر بشكل كبير. الأكسجين والنيتروس أوكسيد في المستشفيات هي مواد مؤكسدة وليست مواد قابلة للاشتعال. هذه من الأخطاء الشائعة نشوفها أحيانا أثناء السيرفي، يكون حاطط الليبل على غرفة الغازات الطبية هي مواد قابلة للاشتعال، وهي مواد مؤكسدة وليست قابلة للاشتعال. corrosive المواد الحارقة. So what is an example of corrosive materials that we have in a hospital? Of course, acids and alkalines. So anything with the pH, when the pH is very high or the pH is very low, it is considered as corrosive. Hydrochloric acid, sulfuric acid, and other. So there are many acids that we have that are corrosive. Sodium hydroxide, it is alkaline. It's something that has very high pH. So high pH is alkalines, low pH is acid. The water is a 7, pH is 7, that's a neutral. Then we have the toxic chemicals. Toxic, that means poisonous, not SAMA. So what is the definition of a toxic? We can say that if it can cause illness or death to human or living tissue. Is that, do you think that it's a clear definition? Any substance that can cause harm or injuries or death to living tissue or living being, whether it's animals or others? No, we can't say. There was a tournament in India who can drink more Pepsi, and one guy drank 2 bottles of these, the large bottle, 2-liter Pepsi, and he died on the spot immediately. So can we say that Pepsi is toxic because one person, when he drank Pepsi, he died? No. Water, if you drink way too much water, your cells will drown and people can die. So we can't say water is toxic. So that definition was missing one word, which is, we're talking about the small quantities, like cyanide and other. So it is a small, any hazardous substance or any substance taken in small quantity that can cause injuries, illness, or death, then that is a toxic. So it has to do with the quantity and the toxicity. فالمواد السامة تعريفا انه اي جزء كميه صغيره من المواد السامه لو اخذتها او شخص اخذها ممكن تسبب اصابه او مرض او وفاه. كنا في تكلمنا على خلط الخليط في مسابقه حصلت في الهند انه مين يشرب بيبسي كميه كبيره، شخص شرب علبتين كبار 2 لتر وتوفى immediately، اصبح في ثاني اكسيد الكربون في الدم نسبه عاليه جدا وتوفى. فما نقول على البيبسي انه ماده سامه. Explosive. قلنا في عندنا unstable chemicals, they can change into explosives, and many of them. So we have, as mentioned, picric acid, or sometimes you have the explosives. You have sodium. Sodium chloride is just a regular item, but sodium by itself is a highly reactive, and it can change into explosive. And we'll see that in reactivity. So the reactivity, then the next one is reactive. Reactive is تفاعل مع الأكسجين أو مع المياه، مثل الصوديوم مثلا المعدن، المادة highly reactive with water. If you put a small amount of sodium in water, it will explode. Potassium, if I put a small amount of potassium in water, it will ignite. حيتحول إلى حريق، إلى مادة قابلة للاشتعال. And so on. The silver nitrate, it exposed to the sunlight too long, it will change into explosives. White phosphorus, it will react with the oxygen in the air and can explode. So it needs a special requirement to deal with it. It has to be an area with low oxygen presence. So chemicals, there is a very wide range. We can talk for days about these properties of chemicals. So as you mentioned, corrosives and caustics. So corrosives, when you have the any chemical with a very low pH or with a very high pH, either it's a basic or alkaline and acid, they are considered as corrosive. So hydrochloric acid is that's 1 mole, that's a 0, that is extremely corrosive. That means when we talk about corrosive, it means it will corrode metal and it will kill living tissue. So if it spells on someone's skin, it will immediately dissolve the skin. It can burn the skin down all the way down to the bones. So this is extremely important to have proper protection when you're dealing with the corrosives. The gloves that we deal with, and regular gloves, surgical gloves that we have at the hospital, they can last the xylene or acids for maybe a few seconds, 10 seconds or so. So you need to make sure that you have the right type of PPEs. You need acid gloves or nitrile gloves. It can last for up to 10 minutes usually with acids or with xylene. So it's very important to make sure that you do have the right type of gloves or right type of PPEs when you're dealing with these corrosives. I witnessed an incident also. Somebody bought a sulfuric acid, 100 kibrit, for his farm. He went to clean the driveway, and he had leftover. He left it in a bottle, in a Pepsi bottle, unfortunately. His son, 9 years old, came and found the bottle a long time after. And he spilled something, he spilled on his thigh and his leg. I was at the National Guard at that time. And of course, the father was smart, so he dipped him in the pool and he took him to the hospital immediately. By the time they called me, I was about 15 minutes away from the hospital. So by the time I arrived, of course, we told them to wash. But the fire department was there and told them, they read in the safety data sheet that do not add water to acid. So the doctors were confused and the nurses were confused. So they did not add water. They did not wash it with water. So they used saline, trying to wash a little bit of the leftover of that chemical in his thigh and his stomach. And that leftover, even though he's been dipped in water already, it burned the tables. That table that was underneath, when they wash it with saline, it burned that table. So we had to discard that table. And the kid has second-degree burns. Unfortunately, if they added water immediately, if they flushed it with enough water, he would have been fine. But just the confusion, and it says do not add water, and what they meant there, you never add water to acid. You always add acid to water. So this is extremely important to understand. So we never make it as a rule of thumb, no matter what chemicals. Always, when you need to make dilution, for example, I have absolute sulfuric acid, 98% or 99%. I need to make 10%. So I need to fill 90% or 90 ml of water. Then I add 10 ml of acid to it. So never add water to acid. Don't start with the acid, then add the water to it. Make it as a rule of thumb. Always start with water, put your water in a container, then add the acid to it. So and that's what they meant by this in the safety data sheet. So they did not wash, delayed washing that exposed area and led to second-degree burn. Otherwise, it would have been he would have been much better. So always make it, again, as a rule of thumb, whenever you have exposure to any chemicals, no matter what it is, always the first thing to do, if you get exposed to it, splash in your face, in your eyes, in your skin, wash it in water for a longer period of time, at least minimum for 15 minutes. Why do you need to wash it that long? So if I rinse it for like 2 minutes, that is enough to wash that chemical off the skin, right? Not at all times. Chemicals are not like bacteria or viruses. It will penetrate through your skin until it fits it now. So I need to wash it long enough to make sure that whatever is been absorbed by the skin to be diluted to a very, very low concentration that will have no effect on us. An example, I'll give you another example. Hydrofluoric acid, not hydrochloric with an F, hydrofluoric acid. If it spills in your hand, nothing will happen. You don't feel any pain at the time. So some people will ignore it. It did not hurt, so it means it's harmful. And they will ignore it. 24 hours later, the pain will start because it will be absorbed through your skin, into your bloodstream, or into the bones, and it will start to dissolve the calcium in your bones. And by then, the damage is done. You cannot even reverse it. Ba'd al-ahmad is always referred to the safety data sheet. Whenever you have an exposure, and no matter what it is, any substance, whether you know or you don't know, wash it with water for a long period of time, at least 15 minutes in running water. Of course, not very cold water, not a warm water, so just a warm temperature, room temperature water. I hope that is clear. Okay, to comply with the regulations, so whether it's a Joint Commission, whether it's SIBAHI, whether it's the Ministry of Health, whether it's any regulatory, the OSHA or anyone, so I need to make sure they all mandate you to have a hazardous material ban. So having a written document Sometimes they ask for a plan, sometimes they ask for policy and procedure. It depends. So Sibahi always asks for a plan. Joint Commission, they ask for a plan. What is the difference between a plan and the policy and procedure? The plan could be similar to a policy and procedure, but I will have goals and objectives because you need to update. So the idea for having a plan that you select KPIs, 2 KPIs, and you need to update it annually. Set a goal and try to see can you achieve it. For example, I need to set a goal to train all my staff. This is a KPI. All staff in the hospital who deal with hazardous material, they need to be trained at least once a year. So this is a goal, try to achieve. If I achieve that goal, then I try to select next year a different goal. Try to see, maybe try to reduce the hazardous waste, for example, by 10% or by 20%. So every year you need to change the policy and procedure, could be up to 3 years. Plan has to be updated every year because you need to set a goal and you need to make sure that if you meet the goal, then you need to set another goal. And same thing for waste management plan. So they could be in one plan, hazardous material and waste management. As we mentioned, they are almost the same, but there are some differences. So you can include them into one plan, that's fine, or you can have them 2 separate, that's also fine. So whichever way you like it, it is fine. قلنا الجوينت كوميشن والسباحي ووزارة الصحة وكل يطلب من كل منشأة لازم يكون في بلان، لازم يكون عندي سياسة للتعامل مع المواد الخطرة ومكتوبة وموضحة ويكون في تدريب للموظفين. According to Joint Commission and Sibahi, we have 2 types. So in your plan, you need to have it's set to the 2 parts: training on the handling, transporting, dealing with the hazardous material, and signs and symptoms. You have to train the staff on signs and symptoms. This is the most funny. Almost 80% of the hospital that we visit, they lack this part. They misunderstand this part. They think we're talking about signages. Well, it's talking about signs and symptoms. الأعراض. لو شخص تعرض إلى مواد خطرة، إيش هي الأعراض ممكن تظهر وكيف ممكن نتعامل معها. So what kind of signs or symptoms that we have if they are exposed, if one person is exposed to hazardous materials? So the first thing that's some chemical, it depends of course on the chemical. So if you're dealing with the xylene or formalin, they have a very strong smell that you cannot even stay in that area, that room, because your eyes will be teary, your sore throat, you have a sore throat, you start coughing, you run your nose. So these are signs that symptoms, and you start coughing because of the exposure to formaldehyde, because it has a very strong smell. But what if you have chemical that does not have a smell? Like in the lab also, they have in microbiology, they have the carbon dioxide incubator, CO2, and that to grow bacteria, because bacteria likes CO2, so it needs CO2 to survive, some bacteria. So they do have CO2 incubator. If there's a leak in that CO2, the area is small, it's a very small room and no ventilation. So what happens is CO2, is it a toxic gas? No, it is not, but it will displace oxygen. It will reduce the level of oxygen in the room. So if you have a leak of carbon dioxide or the nitrogen or the inert gases, they reduce the level of oxygen. So instead of having 21% oxygen in the room, it could drop to 19, or it could drop even lower to 16. That becomes risky. People start to fall asleep, and if no one noticed that, or they did not realize it, they will become unconscious and they can die, asphyxiated. They lack of oxygen. On the other hand, the carbon monoxide is toxic. Even in very small quantities, it can attach to your blood cells, and it will prevent the blood cells from transporting oxygen to your brain and your heart. So that's why people will die. But carbon dioxide has to have a large quantities. The allowed quantities of CO2 is 5,000 parts per million. The allowed for CO, carbon monoxide, is only 5 parts per million. And you see that when you're mandated to do the medical gas or medical air analysis, when you do the purity and humidity, if you pay attention to that, see what is the acceptable quantities in the medical air, you will see 500 parts should be less than 500 parts of CO2 and less than 5 parts per million of CO. Then, of course, we have the labeling. It has to include how to label the chemicals, what system to use. Are you going to use the NFPA 704, or you're going to use the globally harmonized system, the GHS, or you're going to use the OSHA, whichever one. The kingdom now is towards with the Saudi OSHA in hopefully taking place soon. They're working on that, so they will follow the GHS, the globally harmonized system. But a lot of hospitals we go, they use the NFPA. The NFPA is very nice. I like it myself, but it has a problem that sometimes you cannot find these numbers. So we'll talk about that in a minute. You cannot find the numbers that you need, even if you refer to, say, data sheets, you refer to the internet, different numbers. So for activity, for example, you find numbers in different areas. So having difficulty trying to find the accurate numbers. Otherwise, it's a great system, and it's very easy to tell you a lot of hazards without having to read much. And we will talk about that in a few minutes. Storing, how to store chemicals, where to store them, how to store them, and safe handling, transporting. So storing, where do we store chemicals? This is another common mistake, another finding we have in most hospitals. A lot of hospitals, they do have the flammable cabinets, the yellow cabinet that you see it. And that's great. But when we open it, you find it's full of corrosives or full of regular supplies. So they don't store flammables in it. And this comes with the double layers. It has insulation, and it's, God forbid, if fire happens outside, so it will not cause these liquids, or it will prevent the heat from going inside for quite a long time. Or the opposite, if fire happens inside, it will prevent the heat from going outside for a long time. And it has good ventilation that you can have proper connected to a ventilation exhaust system. So they're great to have, but we need to make sure that we use them the right way. And you see the hand gel sanitizers, which it has 70% alcohol, which is highly flammable, or it's a flammable, and you see it stored on the shelf. When you have a flammable cabinets, empty or has non-flammable materials. And again, you have corrosive cabinets. Corrosive cabinet does not have to be ventilated. It does not have to be a double layer, so it could be any cabinet. You can make it out of wood. That's fine. You can make it out of plastic. That's fine. You can put their any activated charcoal. It would be enough to absorb that smell. So you don't need to have proper ventilation for it, or good ventilation. In the shelf, you have to store, if you have not large quantities of corrosives, it is fine to store it on a shelf, but make sure that you put a secondary containment underneath. But flammable, if you have large quantities, it has to be, by law, by OSHA, there has to be in a flammable cabinet. Civil defense mandate to have it in a flammable cabinet. Same thing with Sibahi Joint Commission. But if you have in the small quantities, then it is fine. And there's a formula. It was the OSHA before they had, if you have up to 1 gallon per 100 square feet room. So if your room area is 100 square feet, which is 11 square meters, you can put up to 1 gallon or 3.75 liters of total flammables. Material or substances can be on the shelf. You don't need to put them in a cabinet, in a flammable cabinet. And there, of course, there are a lot of more restrictions. So we need to check based on your quantities how much you have. If your storage connected to the hospital, or if it's outside. If it's outside the hospital, then you can store more larger quantities, and that is fine. On the shelf, you have to store chemicals on the shelf. Then you should never store any chemicals above eye level. So just in case it spills, try to reach out so it doesn't come in your eyes. So always keep your chemicals stored below eye level. Your corrosives, whether it's acids or alkaline, strong corrosives, should be in the lower shelves, close to the floor. So in case it drops or it falls, it will not break. When you transport corrosives, always have a secondary containment, because they usually come in a glass container. So glass container could easily break. As you're walking, you could hit something, or someone can hit you. So you won't have an accident. So have a secondary containment. You'll find in the market there are a lot of like a rubber container that you can put this glass container inside a rubber container. So if even if it breaks, someone hits it, whatever happens, it will contain the acid inside the rubber container. So always during transporting, try to think of that if you're transporting large quantities. Safe handling, of course. How do you know where do you find the information? Your first source of information is the label. The label gives you a lot of information. And by law, no chemicals should leave any factory or any sales place without proper label. So you have the most important information you need is already available in the label. So try to read the label. When you get any new chemical, read the label and go to the safety data sheet. Read the safety data sheet because it's extremely important. Try, even if you don't read the whole safety data sheet, but look at the most important parts. In case of an accident, what happens? How to deal with it? First aid measures. If there's a fire, what to use? Some chemicals, if you add water to it, it will, as we mentioned earlier, it will explode. And some chemicals, if you add water, it will ignite. So it is very important to know what you're dealing with, and have just read more about the chemicals, what it is, what's inside it, what's the properties. Is it flammable? Is it corrosive? Is it does it cause cancer? Does it cause infertility? Does it cause liver failure, and so on? And of course, transporting, as we mentioned. So always make sure that you transport it properly. So closed containers, the right container to close. If it's corrosive, have a secondary containment. And if it's a flammable, keep it away, store it away from heat source. Bicric acid, as we mentioned earlier, need to do maintenance, have a checklist for that, to add water to it every few months. And if you have silver nitrate, store it in a dark area, away from the sun, away from the light. So always read the safety data sheet. It will tell you what the storing requirement, and make sure that you implement that. And usually, silver nitrate comes in a container that is a brownish color, but it will still might get some sunlight in it. So always cover it. If you have it, cover it with aluminum foil, for example, if your room has enough sunlight. So aluminum foil will prevent the sun, direct sun exposure. So try to follow what's written on the safety data sheet and what's written on the label. It tells you that you need to store in cold temperature in a fridge. So we need to make sure that it is stored between less than 4 Celsius degrees. Most chemicals should be stored at the room temperature, but some chemicals, it will tell you that to store it in an explosion-proof fridge. What does that mean? A lot of people probably think like, oh, I need to get a fridge. Where do I find a fridge that is explosion-proof? Or if I have a room says, okay, use electricity that explosion-proof outlets. So it doesn't mean that it will not explode. That means it will be covered, wherever the light is covered with a seal, so spark will not come out. Same thing with the lights. So this is that's what they mean. They don't mean that the fridge itself is not going to explode, or if there's an explosion inside, it will hold the explosion. So just only it means that it will prevent the spark from coming into that, because these probably have a very high flammability property or very, very low flash point. And this is a common mistake also we see during surveys. If you check the medical gas room, you have a lot of oxidizers, as we mentioned, oxygen, nitrous oxide, and stuff. So these, if you have a small spark, that means you started a fire. And these will make, so if you don't have good ventilation, you need to make sure that your outlets, always make sure the outlets, the plugs or switches are explosion proof. That means they're sealed. They will not allow spark to leave that area or that plug. So HAZMAT plan, again, so we need to make sure that the second part, hazardous material plan, must be available. It must be include at least the following, as we mentioned, the goals, SMART objectives. What do we mean by SMART objective? Specific, measurable, achievable, realistic, and time-bound. And this is another common mistake we see. Whenever we see KPI saying, okay, I'm going to train the staff. Okay, which staff? How many staff you're going to train? And how long? You're going to train them in 1 year, or you're going to train them in 5 years? So make sure that it is realistic. Or sometimes say, I'm going to train all my staff. The hospital has 3,000 employees, and I'm going to train them in 2 months. Okay, there's no way on earth you're going to be able to do that, to train them properly, unless you get all these 2,000 employees in a big auditorium and do the training. So try to make sure that it is realistic. It's something that can be done. You need to make sure that you have inventory of the HAZMAT, handling of hazardous material, how to handle, how you don't have to go into a lot of details, but enough detail, because your policy or your plan is a reference for the new employees. So they have to get to that, how to store, how to transport. السياسة أو البلان لازم يكون موجود في مكان العمل، لازم يكون written زي ما تكلمنا أول، ولازم يكون عندي KPIs مؤشرات أداء عشان أعرف إنه أنا في دائما لازم يكون في تطور، لازم يكون في تحسن. فأنا ممكن أختار مؤشر أداء مثلا هذه السنة إنه أقلل المواد الخطرة أو الويست، نفايات الخطرة بنسبة 10% على سبيل المثال. أو أدرب الموظفين اللي يتعاملوا مع المواد الخطرة اللي عندهم مواد خطرة كلهم خلال على الأقل مرة في السنة. فلازم يكون عندي مؤشرات أداء، ولازم مجد يكون في عندي بلان وشوف هل أنا وصلت أتشيف حققت الهدف اللي وضعته في بداية السنة أو لا. هذا شيء مهم جدا. لازم يكون عندي تفاصيل كيف آلة تخزين المواد الخطرة. قلنا المواد الكيميكال كوروسيف والمواد الخطرة بشكل عام المفروض إني ما أخزنها فوق مستوى العين، لازم أحطها على الأرفف على الليفل أقل من مستوى العين. والمواد الحارقة الكوروسيفز اللي هو الأحماض الأسيدز والألكلاينز والبيسز تكون على الأرفف السفلية بحيث لو طاحت أو ما تنكسر. أيضا أثناء نقل مثلا السلفيريك أسيد أو الهيدروكلوريك أسيد، هذه مواد حارقة، لو نقلها من مكان إلى مكان آخر نقلها في كونتينر سكندري كونتينر، في كونتينر وعاء آخر يكون من الربر مصنوع من المواد غير قابلة للانكسار، لو اصطدم في شيء أو انكسر تحتوي المواد القابلة للاشتعال أو المواد الحارقة. وطريقة التخزين أيضا قلنا دائما أخزن كميات محدودة في كل مكان، ما تكون عندي كميات كبيرة. أكثر مكان في المستشفى في الكيميكالز عندي المختبر، إذا خصوصا إذا في هيستولوجي أو سيتولوجي، CSST وحدة تعقيم وحدة غسيل كلى. هذه أكثر 3 أماكن حصل فيها مواد hazardous material أو chemicals بشكل كبير. So we need to make sure إنه إما عندنا غرفة فيها تهوية جيدة جدا، ولازم يكون في ليبل على كل باب فيه، يعني لو أنا عندي هذا غرفة فيها ستور تخزين للمواد الخطرة، لازم يكون عندي على الباب الرئيسي لهذا الغرفة في ساين إنه هنا في عندي مواد قابلة للاشتعال، في عندي مواد حارقة، في عندي مواد مؤكسدة، في عندي مواد مشعة، أي شيء هذا لازم تكون موجودة على الساين. هذه أوشا regulations. الجزء الثاني من زي ما تكلمنا هو الساينز اند سيمبتومز. لازم يكون عندي الأعراض مكتوبة ويتم التدريب عليها الموظفين ويعرفوا ايش هي لو حصل اي اكسبوجر او هذه الأعراض وجدت ايش حيسوي. لازم يطلع من المكان وريبورت، اما اكتيفيت الكود او يتصل على قسم السيفتي، الناس اللي عندهم الانالايزرز ممكن يجي يتاكد انه فعلا هذه المواد خطره. So dizziness or drowsiness, this is one sign. teary eyes الدوخة مثلا أو التدميع في العيون، nausea, vomiting, headaches, and so on. So all of these are signs. Runny nose, sore throat, all of these are signs and symptoms should make you alert if that happened. So and to try to see, for example, we said dizziness and drowsiness. This could happen when you're exposed to carbon dioxide. There's too much carbon dioxide, then there's less oxygen in the air, so it will make you feel dizzy or drowsy. Teary eyes when you have exposure to formaldehyde, metformin, or lizynine, or sulfuric acid. Nausea, when less oxygen, that will make people start to feel nauseated. Some chemicals, the bad part or what happens, for example, we have the chloroform. Chloroform is that used to be in the past they used to use it for anesthesia. مادة كانت تستخدم للتخدير قديما، ولكن المخاطر فيها عالية جدا. هي من المواد اللي ممكن تسبب الوفيات وتسبب سرطان، مواد مسرطنة أيضا. فهذه المادة الآن ممنوع استخدامها إلا في بعض الكميات قليلة جدا. فهذه المادة لو صار فيها ليك، رائحتها جميلة، رائحتها ما تزعجك، وهذه المصيبة لما تشوف الرائحة رائحة ما هي مزعجة، people will ignore it and they pass out and they can die, overdose. So if you have chloroform, it's not allowed to have that anymore, but unless in small quantities. But if you do have it, when there's a leak, the chemical does not smell bad. It smells, actually it has a very sweet smell. So the smell is nice and people will, you don't mind it. But in a few minutes, if you don't have good ventilation, you can fall asleep and you'll be unconscious and people can die because of overdose of that chemical. So you have to be careful. That doesn't mean all bad chemicals that they will have a bad smell. A headache, same thing. The headache can happen when you have low oxygen. That means there's something that's causing that carbon dioxide, or you have liquid nitrogen. This is another high risk we see in hospitals. If you have a derma clinic they use the liquid nitrogen. You have large quantities, they keep that big beaker in the clinic. So you don't have proper ventilation, it will displace because it is the boiling point of liquid nitrogen is 195 Celsius degrees below zero. So it's boiling at room temperature, you can see, and it's heavier than air, so it will displace oxygen. And that could cause people to have these symptoms. I would say if they're not careful, they can cause some serious injury. Also, the other risk with liquid nitrogen, because temperature, it can stay in liquid. It's only between minus 195 Celsius degrees to minus 220 Celsius degrees. So it's extremely cold. It's cryogenic. So if it spills in someone's hand or someone's leg, so that's goodbye for that leg. It's just going to freeze, the cell's going to die, then amputation will have to be done for that organ. So it's extremely risky. So you should not store it in large quantities in your derma clinic. It should be stored away, either in medical gas rooms, away from other gases, or in a separate room with a good ventilation, and you can just have a small beaker that would last for maybe 1 day. So, and it's very important to have the thermal gloves, something that's thick. So when you're filling from the main tank to that small beaker, so in case it spills in your hand, so you have the thermal gloves. So you fill that container, it would be enough to last you for a whole day. And God forbid something happens, a small quantity will not affect, and it's safe. Also, something else that is very important with liquid nitrogen, that it needs to have, the container must have a safety valve or pressure relief valve. So usually you see it either comes in two ways. Either the container itself is open because it boils too much. You can see it just boiling and bubbling, and you get closer, you feel very cold. You feel the coldness from that, and you see that white vapor coming out. So this is one way, and that's fine. Or the other way to reduce the loss, what people do, they have now the new technology, not now, it's been in the market for a while, that has a cover, but there is a safety disc or pressure release disc. So if when the pressure reaches certain amount, it will cause that disc to open. It release the pressure, then it close again. So this way you don't lose that. Instead of filling that container every 2 days, for example, then it could last you 1 week or more, it depends. So that is very important. And accident happened in the States. They tried to save that. It was a large tank of liquid nitrogen. They closed it so it will not evaporate too fast and cause an explosion. It destroyed it. It wiped the entire building. It just the whole building was gone because of that. So be careful of that, and make sure that you do frequent tests of the check. We had an incident, the National Guard. We had the container that had the disc, and something happened, maybe because of the humidity, or it was defective container when we received it. It did explode, but the disc by its own, the only disc that flew away. If somebody was close to it, it would probably could have killed him because it will flew like a bullet. So we have to make sure that your containers are okay and they're checked and they're properly maintained. So remember, again, we'll go back to that equation. We said accidents equal hazard plus exposure. So the logic that if I need to control the hazard, I need to prevent accidents, what's the first thing I need to do? If I try to see, can I eliminate the hazard? Can I remove the hazard? Do I need that hazard in place? Or I don't. So if I don't need it, if I can do without it, then eliminate it. I have hydrochloric acid. If I don't need the hydrochloric acid in my place, then I just eliminate, remove it, then I will remove the accidents. But sometimes, unfortunately, we don't have that choice. So we need that hazardous substance, and it is very important. So in this case, if I cannot eliminate, the exposure, I will try to if I cannot eliminate the hazard, I will try to control the exposure. So how do these chemicals get into our body? And we'll talk about that exposure in a minute. How do these chemicals get into our bodies? As we mentioned earlier, the inhalation is the most common way of entry because the chemicals, they are in form of gases or form of vapor, and we inhale them through our nose. They get into our lungs. Through the lungs, they go to the bloodstream, and they can get into our heart, our brain, and they can cause some injuries. Then the absorption through the skin, as we mentioned earlier. So the same way is for that applies for bacteria. and for the chemicals, except the absorption. So bacteria will not penetrate your skin unless there is a cut on the skin. Sorry. So, but it will. You can inhale it through the inhalation. You can ingest it through when you're eating. You have contamination in your hands. You don't wash your hands. You go to have your lunch, and you eat the small parts of this toxic chemical get into your food, and you ingest it, and people get sick. Or injection. Usually, injection for the most part it is unintentional. Someone's dealing with chemicals. Somehow he gets a needle prick or and gets into their body, and that happens a lot with the nurses when they're extracting blood from a patient or they're doing something. They have a needle prick, or the housekeepers. Sometimes the nurse will throw after they use the syringe or the needle. They don't throw it in the sharps container. They throw it in the regular waste container. So the housekeeper comes trying to pick that container, and they will have a needle prick. So it depends if that needle has hepatitis B virus or hepatitis C or other illness, they get infected. So it's very important to pay attention. So these are the ways. So without these chemicals getting into our system, or these viruses or bacteria getting into our body, we will not get sick. We will not get injured. So they could be around us. They could be everywhere. But if they don't get into our body, we will not be affected. The hazard types. So of course we have the health hazards, or we have the physical hazards. So there are two types of hazards that affect us. Health hazards that can affect us, can cause injuries to human, or injuries to any living animals and so on. So, and there are two types. Could be either acute or chronic exposure. And what is the difference between acute and chronic? Acute is immediate effect. So one exposure is enough to cause injuries. Chronic effect, you need multiple exposures with a high dose or above the permissible exposure limit to cause the injuries. Acute, for example, someone, as we mentioned that example earlier, the sulfuric acid, that child who had to spill sulfuric acid on his leg. So immediately, one exposure is enough to cause severe burns. I've witnessed also seen someone who got, in the market, you can go and buy the chemical for your clogged drain. And these are so powerful. They are so scary. Wallahi, I was so scared when I saw that the material. I bought it, and the guy said, I asked him, is it good? He said, yeah, unless it's rocks that's clogging your sewage, it will melt it. And the guy was not kidding. When I put that material in the drain, I see the reaction, and it in no time it just melted everything. It was just too scary. A friend of mine, her father was cleaning the drain of the kitchen, and she had they missed him. So they're the three girls sitting in the room. The father was in the kitchen. After maybe half an hour, they realized, well, where's our father? He did not come back. So they went to check on him. He was unconscious. From the smell of that chemical, he fell down. It spilled on his shoulder. And by the time they found him half an hour later, they realized the flesh on his shoulder was all dissolved. That meat, it was exposed. The bones were exposed. It was so bad. So they, of course, took him to the hospital, and he had to have multiple surgeries to reconstruct it to fix that. So these are extremely powerful corrosives chemicals. So you have to be careful when you're dealing with that. So this is an acute, that have acute effect. One exposure is enough to cause severe damage. Sulfuric acid, it is available, and you can buy it in the market. They are available in the hospitals everywhere, and it's highly corrosive chemical. Not only the chemical itself is corrosive, but also the vapor, because when you open it, you can smell it. It's a very strong smell. It's a very bad smell. But if you inhale that smell, it could corrode your airway, the breathing airway. It gets into the lungs with the large quantities. It will dissolve, it will corrode your, the mucous membrane in the lungs, that can cause bleeding in the lungs, and people will die. They will drown in their own blood. So it is extremely toxic, extremely hazardous, corrosive chemicals. So you have to be very careful with that chemical if it does happen, or if you have to deal with it. So make sure that you deal with it properly. Make sure you know enough about this chemical and how to protect yourself from that. And sometimes chemicals are incompatible. So we have them, we use at home the Clorox, which is chlor, and you have the ammonia, which is flash. And many people have these at their home. Sometimes, our mother or our sisters or ourselves, we try to clean the bathroom. It doesn't. We use one chemical. It did not work properly. Then I get another chemical. I'll try to make my own magic formula. I mix Clorox with flash, which is ammonia and chlor. And in both, if you read the label of the chemicals, the ammonia tells you do not mix with the chlor, and the chlor tells you do not mix with ammonia. So they're incompatible chemicals. When you mix them together, you can see the reaction starts there. The vapor starts coming out, and it's very bad smell and can kill you if you don't get out. So don't mix chemicals until you are sure. So where do I know? Where do I find that information? I go back to my safety data sheet, try to read, can I mix this with that? Is it incompatible? Is it compatible with this or not? Some chemicals, as we mentioned earlier, so when you mix them together, then you will have a very powerful or very toxic chemical or very highly reactive chemical that can explode. And vice versa. Some chemicals, they could be too toxic. If you mix them together, and you will have non-toxic outcome. And it could be the opposite. Two non-hazardous, you mix them together, then you will have a very hazardous or very toxic chemicals. So the acute exposure is one exposure is enough to cause injuries. The chronic effect or chronic exposure, it will take years. For example, the exposure to xylene, exposure to formalin, exposure to toluene. There are many chemicals that can cause cancer in the long term. So you have to be exposed to these chemicals above the permissible exposure limit, the PEL, which is defined by OSHA, for a long period of time. So if that happens, people will either can get cancer, or they can get renal failure, or they can get kidney failure, liver sclerosis, or they can have central nervous system failure. So, and that is very bad. Or sometimes people will have sterility; they will not be able to have children anymore, or they will have mutation in the gene, so they have whenever they have kids, they could be deformed. So there is a large effective chronic effect of this chronic exposure. المواد الخطرة لها نوعين من التعرض، في بعضها يكون في الأكيوت، الإصابات الحادة اللي ممكن إصابة واحدة تسبب أو تعرض واحد لهذه المادة تسبب إصابة، أو في بعضها التعرض المزمن، الأمراض المزمنة يتعرض واحد إلى هذه المواد يوم بعد يوم بعد يوم في مجال العمل، وحتسبب بعد فترة زمنية طويلة سنوات يصير عنده إما سرطان، أو يصير عنده فشل كلوي، يصير عنده سرطان في الكبد أو في الرئة أو يصير في شلل بسبب مشاكل تصل إلى نظام السنترال نيرفس سيستم، اللي هو نظام أو النظام التنفسي، نظام الأعصاب. أو الفيزيكال هازاردز عندنا هو الفاير اكسبوجر أو كونتامينيشن. ممكن الكيميكال زي ما قلنا الصوديوم لو ميكست مع with water it will explode، حيصير عندي explosion. Potassium, if I mix it with water, it will ignite. And contamination, of course, if I have a leak of hazardous material leak, then it will go into the drain, it can affect our drinking water, or it can affect the ozone layer just from all the carbon monoxide of the cars, the combustion of the diesel and fuel gas. It causes pollution to the air and causes the global warming. It's affecting our ozone and affecting our plants. So the acute single exposure, as I said, through the absorption, it can cause eye irritation, blurring eye, blurred vision. So people will be affected. Okay, I guess we're going a little bit. Gotta go a little bit faster just to make sure we're almost done. And we've covered that. The skin, as we mentioned, rash, dryness, burns, ingestion, nausea, unconsciousness, death. acute, again, single exposure. For inhalation, we mentioned headaches, dizziness, nausea, vomiting. We mentioned all of that. And chronic effect, throat, lung damage, liver, kidney damage, central nervous system damage. Okay, so exposure limits, as we mentioned earlier, the permissible exposure limit, PEL, that's the amount limit that you're allowed to get for 8 hours. Threshold limit, TLV, that's set by the different entities, but this is what recommended to have through your lifetime. So that exposure, as long as, because it will accumulate. The time-weighted average, that's how much you get in 8 hours. You take the average of it, and that's how much you're allowed to get within a working day. And short time exposure limit, STL, that's the maximum exposure you can get within 15 minutes. For example, formalin, it has the permissible exposure limit of 50 parts per million, but the short time exposure limit is 200 parts per million, because only for a short period of time then you make up. The recommended exposure limit is recommendation by NIOSH, and that's what they recommend. That's a lower limit. These we covered fire exposure and contamination. Fire, I think we're all familiar. We will not go much in details about fire. Protection and prevention is better than the cure. How can I prevent fires? I have flammable materials. I need to train the staff. I have good housekeeping, keep flammable materials away from hazardous substances. Proper storage, we mentioned that we all know the fire triangle, that 3 elements of fire. That if I remove one of the elements, the fire is usually out. So try to work that prevention, trying to keep one of these elements away, or keep away these elements, so I'll never have the good environment for fire. Last point we already covered. Okay, this is important, the upper and lower limit. So you see this is LEL and UEL, upper exposure limit, or sometimes upper flammable limit and lower flammable limit. That means that chemical can only ignite or explode when it's between these two limits. So when it's less than that, that means it's too little concentration, will not ignite. And if it's higher than that, that means the concentration is too rich, not enough oxygen for it to happen. So these are just only examples. For example, you can see the ones that has a very wide range, the ethylene oxide, that is the most dangerous, or the most hazardous. Compressed gases, we mentioned that in the place, we need proper storage, proper handling, proper transport. Of course, as you can see in this picture, stored without the caps, and here they are not secured, so that's wrong. So this proper storage, proper transport, and proper storage. They should be secured to the wall, and they should always use the right way. Also try to segregate, so keep flammables away from oxidizers, at least 6 meters away. If you can't, keep them in separate holes. So if you have, for example, acetylene, store it away from oxygen or nitrous oxide. They should be stored upright. The area should be well ventilated and secured, cap away from heat source, away from oils and grease, and always flammables away from oxidizers, and safety signages in the doors. When you receive your cylinders, make sure that's not leaky, so it will not cause saturation of the oxygen. Check for butyl amount, that's recommended by SPAHI or mandated by SPAHI. Same thing for medical gas pipes. So we need to check for leak, make sure that you have proper direction, proper signages, and the medical gas pipes, direction and the type of gas, and check for leak by either consumption or by the differential pressure between the manifold and different area far from the manifold. And of course, check the valve. We're going to watch this quick, what is the hazard in this cylinder. Then after that, we'll cover briefly.
When a typical cylinder is filled to its design pressure of 2400 psi, it will contain almost 300 cubic feet of atmospheric pressure gas, or about 160 times the internal volume of the cylinder. This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas can turn the cylinder into a missile with energy to shoot through a cinder block wall. In one reported incident, A damaged cylinder penetrated 2 sheet metal walls before becoming airborne and exiting through the roof. The tank reached an altitude of 140 feet before falling back through the building's roof a second time. When a steel cylinder becomes a projectile, it can move with great force, at high speeds, and in unpredictable directions, with the potential to cause serious or fatal injuries.
I think that's self-explanatory. We don't have to explain that. That is the risk of cylinders. That's why they have to be chained, and we need to have the cap on at all times. And we covered that. Okay, we covered the labels. Okay, the safety data sheet. So there are 16. The GHS. Okay, the GHS label that it has usually through 3 different parts. The elements, the product identifier, the name of that chemical, the symbols or the pictogram. There are 9 different types of pictogram, signal word, and hazard statement, and the precautionary statement. And we can see an example. So these are the first one is an oxidizer. That's a flammable, explosive. That's a poisonous or toxic, or highly toxic. This is corrosive, compressed gas cylinders. This is health hazard that could be can cause cancer, can cause central nervous system, can cause other illness, and this is harmful to the environment. And this is irritant, or there are other health hazards that they are not aware of. Signal word is shows the severity of the bustle. They could be either saying warning or danger. So warning that has less hazard, danger has more hazard. Hazard statement describes the nature of the hazard, the chemical. For example, tell you that physical hazards, health hazards, environmental, so causing eye damage, for example, or toxic if inhaled. Precautionary statement measures to prevent and minimize adverse effects. So it will try to tell you what to do to prevent injuries. So keep away from heat, do not eat, do not drink or smoke while using this product. And this is an example of GHS has label for methanol. So you can see the name of the chemical, methanol, that tells you danger. That's then you see the pictograms. It's toxic, it's flammable, and health hazard. And the name of the company with the address, phone number. I will tell you what to do. Okay, the NFPA. I guess we're gonna skip the NFPA just because of time's sake. I'm sorry, because we're talking 2 different languages, is a bit delayed. And we're going to go to the safety data sheets. Again, we'll skip through that. And when you need a hazardous safety data sheet is when you have hazardous, any chemical have either health hazard or physical hazards. Handling a hazmat spill, you need to have a spill kit, of course. You can make your own spill kit. You don't have to buy it ready, or if you buy it ready, it's fine. So what's inside? You need to have a dust pen and a broom in case there are glass pieces broken, or a forceps. You need to have acid gloves, a bag, and you need to have labels to label it, and of course a goggles, safety, shoe cover if you have, that would be great, and absorbent. When there's a spill, the first thing to do is not to panic. So when you panic, you run into walls, you run into problems, you don't know what to do. So stay calm, alert people, and never clean a spill alone. Always have someone else assisting you with the spill, keeping an eye. So, and that's if you have a spill. How do I decide whether it's a small spill or a large spill? It's usually to do a quick risk assessment based on the hazard. If it's highly flammable and I don't have ignition source, then it's not a big deal. But if it's highly toxic, even if it's a small quantities, it will be considered as a large spill. So I need to have proper PPEs and I need to activate the code. And how do I handle the spill? I need to cover around the spill, prevent it from spreading. If the container is still spreading, I will try to stop it. But the first thing I need to do is wear my PPEs, make sure that I have the right PPEs, then try slowly cover that whole area, let it absorb all the material, then scoop it, put it in a plastic bag, biohazard bag, label it with the name of the chemical or chemicals that they were spilled. And if you use any spill kit, mark the spill kit, the name of a spill kit that you use, because that's additional chemicals. Then you can send it as hazardous waste. Contaminated victim, if you have someone who's contaminated, before you bring him to the ER, he should be decontaminated outside so you don't contaminate the ER. Hazardous waste, we've covered that, just already the same. The hazard control, as we mentioned earlier, the hazard, I can try to prevent the hazard. If I cannot eliminate the hazard, then I will eliminate the exposure. And we all know the hierarchy of control: elimination, substitution or reduce, engineering control, administrative control, and PPEs. So if you cannot eliminate or reduce, try to use the proper ventilation, administrative control, policies, procedures, training, and PPEs, of course. Okay, radiation, we'll spend probably 10 more minutes, so then we will be done. Okay, so radiation, we have 3 types of radiation. We have the radiation, the X-ray from the machines that we have in our hospital, X-ray machines for scopy. We have from CT. We have radioactive materials. So how do people get affected? Why do they need to wear their PPEs? Or they're not allowed to stand next to the machine? Because we have scattered radiation. Sometimes heat, or when it hits the person, it will just scatter all over the place and hit the people. So how do I protect people from radiation? There are 3 factors for protection, which is time, and distance, and so this is something new that came up, that you need to justify or optimize the unit. Why do you need to request an X-ray, for example? Not only the insurance, sometimes we think just the insurance doesn't want to pay, but sometimes that is one reason. But the other reason is we as humans sometimes ask for a second opinion. You get an X-ray, you go to another hospital, you get another X-ray, you go to a third hospital, you get another X-ray. So all these X-rays affecting your body, it's built up and it will accumulate in your body. So that's what they mean by justification and optimize. So if I've done an X-ray, I can take the report and they should accept that, because I don't want to have the X-ray because it will affect my genes, it will have a huge effect on my body. It will accumulate in my bloodstream. And the LR, that means as low as reasonably achievable. So try to keep the patient or any person exposed as little as possible to radiation. So the radiation protection principles is the time, distance, and shielding, as we mentioned earlier. So the shorter the time, the less exposure that I have. So if one person is exposed for an X amount of time, he will get an X amount of dose of radiation. If he's exposed to 2X, he's going to get 2X dose. So double exposure, double the time. So 3 minutes exposure will give you a certain dose. So if you're exposed to 6 minutes, it's going to give you double that dose. The distance works a bit differently. So if the further away you are from the source, the safer you are. So if you are 1x away from the source, then it's 1 over x squared time. So if you're 2 meters away from the source, so you'll be 1 over 4, 1 quarter dose. 3 meters away, or 3x, you're 1 over 9 the dose. So you reduce the dose tremendously. 4 meters, 1 over 16 of the dose. So distance is a great way to keep from getting exposure. And of course, the shielding. Shielding, which is material used between the source and the person. So it could be the PPEs, the lead aprons, the gonad, the thyroid shields, or even the room itself when you do the shielding of that room. So lead, water, or concrete can be a good base on the source of radiation. Lead works for X-ray, and water works for neutrons and radioactive materials, and concrete. Protective clothing protect against radiation hazards and keeps radioactive materials off your skin and your clothes. So whenever you're dealing with radioactive materials, you need to make sure that you have your PPEs. The difference between radioactive materials, we're going to see them here. These alpha, beta, gamma, and neutron. So the alpha, beta, and these are particles. They are continuous source of radiation. And so whenever you have the radioactive materials, at all times it's producing radiation, because that particles, the alpha or beta, they are because of decaying, they are coming from the nucleus of that atom, and it will be affecting people. The alpha can travel only about 0.4 meters or 40 centimeters at a maximum, because it's a very large particle, and it will not penetrate through the skin. So your skin will stop it, or a piece of paper will stop it. The beta is a little bit more, it's smaller, it's much faster, and it goes up to maybe 40 meters, 10 times. So 4 meters, 10 times the dose, and plastic will stop it, but paper will not stop it. It will penetrate human tissue. It can penetrate through a person. They can alter the genes. They can cause cancer. They can cause a lot of other illnesses, but you can't stop it with the plastic. Gamma and X-rays, they will penetrate through paper. They penetrate through plastic. They penetrate through human bodies, and they can be stopped by lead. So you need to depends on the strength of the machine and the distance from the wall, that will decide how much lead I need to use the wall to have the shielding to protect that room from radiation going outside that room. Then the neutrons, they will penetrate through paper, plastic, lead, human bodies, and they can be stopped by large amount of water if there's a big layer of water, because anything with a high hydrogen will affect, or concrete. They usually use the concrete walls to stop the neutrons. So having proper PPM, the shielding the room, that's to make sure people are not affected. If the machines here, need to make sure that I'll check these areas, the doors, the outside, all these areas, and I'll check for the annually. I need to make sure that there's still no penetration into that from these areas. I need to do proper PPM to the equipment to prevent the scattered radiation. And watch this last video, and this is the last part of our presentation. So let's watch the video.
If a radiation emergency happens in your area, you can protect yourself, your loved ones, and your pets. No matter where you are, the safest action to take immediately after a radiation emergency is to get inside, stay inside, and stay tuned. If you are outside or in a car, bus, or other vehicle, get inside a building right away. Cars do not provide good protection from radiation outside. If you have pets, bring them inside with you if you can. Radioactive material settles on the outside of buildings like dust or mud, so the best thing to do is stay either in the basement or as far away from the walls and roof as you can. Close and lock all doors, windows, and fireplace dampers, and turn off fans, air conditioners, and forced air heating units that bring air in from the outside. Once you are inside, stay tuned for updated instructions. Television, radio, and social media may be used to share more information. Remember, immediately after a radiation emergency, the safest action for yourself, your loved ones, and your pets is to get inside, and stay tuned.
Thank you very much. شكرا، واعتذر على الإطالة. جزاكم الله خير، واتمنى انه ما كانت مملة وكان فيها فائدة.
الله يعطيك الف عافية استاذ جمال. يعني حقيقة كانت المحاضرة مليئة بالمعلومات الجميلة والقيمة، واللي انا متأكد انه الجميع استفاد منها. نكرر اعتذارنا مرة أخرى لجميع الأشخاص اللي كانوا يرغبون بالحضور، ولكن بسبب الخلل الفني لم نتمكن من يعني السماح لهم بالدخول داخل المحاضرة. المحاضرة هذه مسجلة، كل الناس اللي حضروا معنا راح تصدر لهم بإذن الله شهادات من الجمعية. بالنسبة للآخرين هناك تسجيل لهذه المحاضرة، وراح يكون في تراكينج إن شاء الله عليها، بحيث الشخص اللي يحضرها كمان باليوتيوب كاملة يستحق الشهادة. شكرا جميعا. ما قصرت والله أستاذ جمال على المحاضرة القيمة، وأنا متأكد كثير من الناس يعني يسعى لها ويعني تمكنا الحمد لله بفضل الله من توفيرها بشكل يعني مجاني للجميع لنشر العلم. فشكرا جزيلا لك ولكل الحاضرين، وبإذن الله أن يعني نتمكن من تقديم المزيد في المحاضرات القادمة بإذن الله. شكرا لكم.
وحياكم الله، يعطيكم العافية جميعا. شكرا.